When we think of Antarctica, we picture endless ice, research stations, and penguins. But that's only the surface. The truth is, beneath miles of ice lies a continent we've barely begun to understand. Satellite imagery has revealed strange formations. Expeditions have stumbled upon anomalies that don't fit standard geological explanations. Whole mountain ranges sit hidden beneath the ice sheet. Ancient maps seem to show coastlines that shouldn't exist. And between the official reports and the classified files, questions linger. It's in that frozen silence that speculation grows. What was Antarctica before the ice consumed it? Satellite scans show pyramid-shaped peaks rising from the ice sheet, their angles too precise, their proportions too regular. Some researchers claim these are natural formations, mountains sculpted by wind and glaciers over millions of years. Others point to measurements that mirror the Great Pyramids of Egypt and Mexico. Maps from the 16th century appear to depict the continent's true coastline. Expedition reports hint at discoveries never fully disclosed. And between those fragments of evidence, uncertainty. Between the geological explanations and the archaeological possibilities, silence. This won't be a straight lecture or a neat timeline. Think of it instead as a journey, one where we examine the evidence and look at it together. Some claims rest on satellite data and expedition reports. Others are interpretations, theories that push against conventional geology and history. So, wherever you are right now, sit back, relax, and feel free to let this play in the background. The visuals are here for context if you want them, but they're not necessary. You can just listen, follow along, and let the discoveries unfold. And to begin, we start not with ancient history, but with modern technology, satellite imagery that captured something in 2016 that no one expected to find. In 2016, satellite imagery revealed formations in the Ellsworth Mountains that sparked global debate. What analysts saw were angular peaks rising from the ice, their geometry too precise, their proportions too regular. Were these natural mountains sculpted by wind and ice, or evidence of something far older? The discovery spread through online forums and alternative research communities, though pinpointing the exact moment of first observation is difficult. Google Earth, which compiles imagery from multiple satellites, including Landsat and commercial providers, made the Antarctic interior accessible to anyone with an internet connection. Coordinates began circulating. The most discussed formation sits at 79 Kaikschnickfights 3995 S, A9195 W, deep in the Ellsworth Mountain Range, one of Antarctica's most remote and inhospitable regions. The formation isn't a single peak, but a cluster of three. Each rises from the ice sheet in what appears to be pyramidal form. The slopes are steep and uniform. The ridges converge at sharp apexes. From directly above, the symmetry is striking. The central peak appears to be the largest, estimated at over 1,200 feet from base to summit, though measurements through satellite imagery carry uncertainty, especially when ice obscures the true base level. The other two peaks flank it at regular intervals, creating what some describe as a complex rather than a random arrangement. For comparison, the Great Pyramid of Giza stands 481 feet tall, about 40% the height of the largest Ellsworth Formation. The base measurements are harder to determine through ice, but researchers analyzing the imagery have suggested proportions that loosely mirror those of ancient pyramids. The angles of the slopes appeared to fall within ranges used in human construction, though natural mountains can achieve similar angles through erosion. What makes these formations controversial isn't just their shape, it's their context. The Ellsworth Mountains are among the most remote ranges on Earth, far from any research station, rarely visited, and visible primarily through satellite imagery. The nearest permanent base is hundreds of miles away. Physical access requires specialized equipment, aircraft capable of extreme cold weather operation, and permits that are difficult to obtain. This remoteness means that ground-level verification remains scarce. We see the peaks from orbit, but few have stood at their base. The satellite images themselves are clear enough to show detail. Shadows cast by the Antarctic sun reveal the three-dimensional structure. The peaks aren't hidden by snow, but protrude as dark rock, their surfaces too steep for ice to accumulate. This exposure allows for analysis, but it also raises questions. If these are natural formations, why do they appear so distinct from the chaotic, irregular profiles of surrounding mountains? If they're artificial, how did they survive beneath or atop ice that has covered the continent for millions of years? Geologists examining the imagery point to known processes. Horn pyramids, formed when glaciers erode a mountain from multiple sides, create sharp, pyramid-like peaks. The Matterhorn in Switzerland is the classic example, but the Ellsworth formations don't perfectly match that explanation for everyone. Some researchers note that the clustering of three similar shapes suggests either an unusual concentration of erosional processes or something else. Imagine viewing Antarctica from orbit, scanning endless white ice fields, when suddenly three dark peaks emerge in formation, each one rising in perfect pyramidal geometry. The contrast is stark. The surrounding landscape shows typical mountain ranges, jagged and irregular. These three stand different. Whether that difference is geological coincidence or something more significant is where interpretation diverges. The discovery, or rather the attention it received, divided observers. Mainstream geologists expressed little surprise, noting that pyramid-shaped mountains are common in heavily glaciated regions. Alternative researchers saw something anomalous, evidence worth investigating further. The images went viral in certain communities, analyzed and reanalyzed, measured and speculated upon. Yet despite the attention, no funded expedition has been mounted specifically to examine these peaks at ground level. The cost, the logistics, and the lack of institutional interest have kept them accessible only through pixels on a screen. There are tidbits that add intrigue. Some analysts claim to detect regularity in the spacing between the peaks, suggesting intentional placement. Others note that the rock type visible in the imagery appears different from the surrounding geology, though definitive identification of rock composition through satellite alone is limited. The formations have been nicknamed the Antarctic Pyramids in online discussions, a label that carries assumptions but has stuck nonetheless. So the question remains, are these perfectly symmetrical peaks the result of millions of years of erosion, shaping rock into pyramid forms by pure chance? Or could they be evidence of construction from an age when Antarctica was ice-free? The formations are real. The satellite imagery is verified. What they represent is where the debate begins. To understand whether these could be artificial, we first need to know when Antarctica was last habitable And that takes us back millions of years to a continent that looked nothing like the frozen wasteland we know today. To understand whether these could be artificial, we first need to know when Antarctica was last habitable. And that takes us back millions of years to a continent that looked nothing like the frozen wasteland we know today. Fossil evidence proves that Antarctica once supported forests, rivers, and diverse wildlife. The question is when, and whether any of it overlaps with human history. Picture Antarctica 50 million years ago, during the Paleocene and Eocene epochs. The continent sat further north than it does today, not yet locked over the South Pole. The climate was temperate, perhaps similar to modern-day Chile or New Zealand. Forests of southern beech and conifer covered the landscape. Rivers carved valleys through volcanic rock. Along the coasts, shallow seas teemed with marine life. And walking through those forests were animals we'd recognize only from fossils elsewhere. The evidence comes from excavations across the continent, though ice cover limits where paleontologists can dig. In the Trans-Antarctic Mountains, researchers have uncovered fossilized wood, leaves, and pollen that date back tens of millions of years. The wood shows tree rings, proof of seasonal growth cycles. The leaves belong to species adapted to cool but not freezing temperatures. In some deposits, the fossils are so well preserved the cellular structure remains visible under microscopes. Animal fossils tell a richer story. In 1991, on Seymour Island near the Antarctic Peninsula, paleontologists discovered Cryolophosaurus, a crested theropod dinosaur that lived roughly 190 million years ago, long before the ice. The find proved that Antarctica once supported large predators, which means also supported the prey species and plant life necessary to sustain them. Mammal fossils from later periods show that Antarctica remained habitable even as the climate cooled. Marsupials, distant relatives of modern Australian species, once roamed there. But the transformation from green to white was gradual and then catastrophic. About 34 million years ago, Antarctica reached the South Pole as continental drift slowly repositioned it. Ocean currents changed. The circumpolar current began flowing around the continent, isolating it thermally from warmer waters to the north. Temperatures dropped. Snow that fell in winter stopped melting in summer. Year by year, the ice accumulated, first in the mountains, then spreading across the lowlands, until the entire continent was buried beneath an ice sheet that in places reaches nearly 3 miles thick. Ice core samples drilled from the interior confirm this timeline. The Vostok ice core, extracted by Russian researchers, reaches back 420,000 years. But the ice itself sits atop bedrock that has been frozen far longer. Sediment cores taken from the ocean floor around Antarctica show the transition from temperate forests to glacial conditions, with pollen giving way to glacial sediment around 34 million years ago. The dating is consistent across multiple methods. The ice is old, far older than human civilization. Temperature reconstructions paint the contrast starkly. During the Eocene, Antarctica's interior may have averaged around 50 degrees Fahrenheit, warm enough for forests and rivers. Today, the interior averages negative 76 degrees Fahrenheit, cold enough to freeze carbon dioxide out of the air. The ice sheet contains roughly 26.5 million cubic kilometers of ice, about 90% of all the ice on Earth. If it melted, global sea levels would rise by nearly 200 feet. Yet there's a complication. Some ancient maps, drawn centuries before Antarctica's official discovery in 1820, appear to show the continent's coastline in detail, sometimes depicted without ice. The most famous is the Piri Reis map of 1513, which includes a southern landmass that some researchers argue matches Antarctica's true coastline, hidden today beneath ice shelves. If those maps are accurate representations rather than speculation, they suggest knowledge of Antarctica in a state we're told hasn't existed for 34 million years. The evidence is clear that Antarctica was once warm and habitable, but the timeline matters. If the last ice-free period ended 34 million years ago, long before humans evolved, could any civilization have existed there? Or do some maps and theories suggest the ice is younger than we think? From ancient climate to ancient maps, we turn to cartographic mysteries that some claim show Antarctica without ice centuries before its official discovery. From ancient climate to ancient maps, we turn to cartographic mysteries that some claim show Antarctica without ice centuries before its official discovery. In 1929, workers renovating Istanbul's Topkapi Palace discovered a fragment of an Ottoman naval map tucked among stored documents. Dated to 1513 and drawn by Ottoman Admiral Piri Reis, it showed South America's coast in remarkable detail for its era. But it also depicted something else, a landmass to the south that some researchers believe is Antarctica, mapped 3 centuries before the continent was officially discovered in 1820. The map is a fragment, roughly a third of what was likely a complete world map. It's drawn on gazelle skin parchment and colored with inks that have survived 5 centuries remarkably well. Piri Reis himself wrote notes on the map, explaining his sources. He claimed to have consulted about 20 older maps, including charts captured from Spanish sailors, and possibly maps dating back to the time of Alexander the Great. One note specifically mentions a map used by Christopher Columbus, suggesting the admiral drew from ancient sources rather than discovering entirely new territory. What caught attention was the southern landmass. On the Piri Reis map, a coastline extends below South America, detailed with bays, inlets, and geographic features. When researchers compared this coastline to Antarctica, they found what appeared to be similarities. Mountains were shown where mountains exist beneath the ice. Coastal features seemed to align with Antarctica's actual geography, though the shape wasn't perfect. In the 1960s, Charles Hapgood, a professor of history at Keene State College, analyzed the map extensively. Hapgood proposed that the Piri Reis map, along with several other ancient charts, showed Antarctica as it appeared before ice covered it. He argued that the level of detail and accuracy suggested an advanced cartographic tradition, stretching back thousands of years, perhaps to a lost civilization that mapped the world when Antarctica was ice-free. His book, Maps of the Ancient Sea Kings, published in 1966, brought the map into popular discussion and sparked decades of debate. Mainstream cartographers and historians offered a different interpretation. They pointed out that Renaissance maps routinely depicted Terra Australis, a hypothetical southern continent that European geographers believed must exist to balance the landmasses of the Northern Hemisphere. This wasn't based on actual exploration, but on theoretical geography inherited from classical Greek sources. Ptolemy and other ancient geographers speculated about southern lands. Medieval and Renaissance mapmakers continued this tradition, drawing southern continents based on expectation rather than observation. The similarities between the Pori race map's southern landmass and Antarctica, critics argue, are either coincidental or the result of seeing patterns we want to see. When measured precisely, the coastline doesn't match Antarctica nearly as well as initial impressions suggest. The scale is wrong. The proportions are distorted. Features appear in incorrect positions. What Piri Reis likely drew was a speculative extension of South America, combined with rumors of lands to the south, filtered through multiple copying generations and geographical theories popular in his time. There are fascinating details that complicate both interpretations. Piri Reis's notes mention that his sources were very old, some possibly from the Library of Alexandria before its destruction. If those sources existed, they might have contained genuine geographic knowledge from antiquity, though whether that knowledge included Antarctica is another question entirely. The map's depiction of South America is notably accurate for 1513, showing details that Spanish explorers were only beginning to chart, which lends some credibility to Piri Reis's claim of consulting earlier, high-quality sources. Another complication is the Oronteus Phineas map of 1531, which also shows a southern continent with surprising detail. That map depicts the landmass as more clearly separate from South America, and its shape bears an even stronger resemblance to Antarctica. When multiple maps from the same era show similar features, it suggests either a common source tradition or a shared theoretical framework. Which explanation is correct depends on how we interpret the accuracy of their depictions. The debate reveals the challenge of historical cartography. Maps from this period mixed observation, theory, copying errors, and artistic interpretation. Separating what mapmakers actually knew from what they speculated or inherited from earlier traditions is difficult. Piri Reis was undoubtedly skilled, and his map represents impressive geographic knowledge for its time. Whether that knowledge extended to accurately depicting a continent that wouldn't be officially cited for another 3 centuries is where consensus breaks down. So did ancient mariners map Antarctica before modern discovery, working from sources that predate the ice? Or is the resemblance to Antarctica's coast the result of speculation about Terra Australis, a mythical southern continent that mapmakers expected to find? The map exists. Its southern features are documented. The question is whether those features represent genuine knowledge of Antarctica or Renaissance geographic theory that happened to land near the truth by chance. While maps offer tantalizing hints from the past, the modern evidence lies in expeditions to the ice itself. And that brings us to Operation High Jump, the massive 1947 US Navy mission that some claim uncovered far more than was ever disclosed to the public. While maps offer tantalizing hints from the past, the modern evidence lies in expeditions to the ice itself. And that brings us to Operation High Jump, the massive 1947 US Navy mission that some claim uncovered far more than was ever disclosed to the public. In the austral summer of 1946-47, Admiral Richard Byrd led 4,700 men, 13 ships, and 33 aircraft to Antarctica. It was the largest expedition ever mounted to the frozen continent. The official purpose was mapping and establishing research infrastructure. But the mission ended abruptly after just 8 weeks, instead of the planned 8 months. Why? The expedition's scale was unprecedented. The task force included the flagship USS Mount Olympus, the aircraft carrier USS Philippine Sea, the submarine USS Senate, 2 destroyers, 2 cargo ships, 2 tankers, and several support vessels. The aircraft complement consisted of 6 R-4D transport planes, 6 Martin Mariner flying boats, 6 helicopters, and various other aircraft for reconnaissance and logistics. For comparison, most previous Antarctic expeditions involved a single ship and perhaps a few dozen men. Operation High Jump brought an armada. Admiral Richard Byrd was no stranger to polar exploration. He had led expeditions to Antarctica in 1928 and 1933, becoming one of the most famous explorers of his generation. He claimed to have been the first to fly over the North Pole in 1926, though that claim remains disputed. By 1946, Byrd was a national hero, a veteran navigator and polar expert whose leadership lent credibility to the mission. The Navy chose him specifically because of his experience navigating Antarctic conditions. The official objectives were straightforward, according to Navy documents. The expedition would establish a research base called Little America of Furfur on the Ross Ice Shelf. Aircraft would conduct aerial photography to map the coastline and interior regions. Scientists would gather meteorological and geological data. The Navy would test equipment and personnel in extreme cold weather conditions, valuable experience as Cold War tensions with the Soviet Union were beginning. And the United States would reinforce its territorial claims on the continent, establishing presence ahead of competing nations. Operations began in December 1946. The ships reached the Antarctic coast and established base camps. Aircraft began reconnaissance flights, photographing vast stretches of territory. The helicopter component, particularly innovative for its time, allowed for inland exploration that previous expeditions couldn't achieve. For several weeks, the mission proceeded according to plan. Thousands of aerial photographs were taken. Coast surveys extended existing maps. The crew adapted to temperatures that routinely dropped below negative 40 degrees Fahrenheit. Then in late February 1947, Admiral Byrd ordered the fleet home. The expedition had accomplished only a fraction of its planned objectives. Of the planned 8 months, only 8 weeks had passed. 3 men had died in aircraft accidents. Equipment had frozen and malfunctioned. But early returns from polar expeditions weren't unprecedented. What sparked speculation were Byrd's comments afterward. In interviews given shortly after his return, Byrd made statements that fueled decades of conspiracy theories. He allegedly spoke of a land beyond the pole, vast territories yet to be explored, and resources that could transform nations. The exact quotes are difficult to verify, as many appear in secondary sources rather than documented interviews, but they circulated widely. Some claimed he described encountering advanced technology. Others said he warned of threats from the polar regions. The lack of detailed official reports added to the mystery. While some expedition data was published, much remained classified under Navy protocols. The official explanation for the early termination was practical. Weather conditions were harsher than anticipated. The Antarctic winter was approaching, and continuing operations risked trapping ships in ice. Equipment failures had degraded operational capacity. The deaths of 3 crew members in separate aircraft accidents sobered the mission planners. Limited funding in the post-war period made extending the expensive operation difficult to justify. When weighed against risks and costs, Navy leadership decided to withdraw while conditions allowed safe passage. Declassified documents support this straightforward narrative. Mission logs, describe equipment struggles, dangerous weather events, and the logistical challenges of supplying thousands of men in the most remote environment on Earth. The aerial photography that was completed proved valuable, filling in gaps in Antarctic maps that would serve researchers for decades. The cold weather testing informed later military operations in Arctic and Antarctic environments. By official measures, Operation High Jump accomplished significant objectives despite its abbreviated timeline. Yet the gap between planned duration and actual duration remains a point of fascination. 8 months compressed to 8 weeks suggests either catastrophic problems or discovery of something that changed mission parameters. Weather and accidents explain early departure, but the scale of the expedition, the resources committed, and the abrupt conclusion have kept speculation alive for more than 7 decades. Was Operation High Jump cut short because researchers encountered something unexpected, discoveries that remain classified to this day? Or did harsh weather, equipment failures, and the loss of aircraft force a premature end to an overly ambitious polar mission? Official records document the practical challenges. The theories about hidden discoveries rest on absence of evidence and cryptic statements that may not be accurately attributed. The expedition happened. Its early return is documented. What caused that return depends on whether we accept the official explanation or suspect something remains undisclosed. From military expeditions with cameras and ships, we move to modern technology that sees through the ice itself, and that leads us to ground-penetrating radar discoveries that revealed what lies beneath Antarctica's frozen surface. From military expeditions with cameras and ships, we move to modern technology that sees through the ice itself, and that leads us to ground-penetrating radar discoveries that revealed what lies beneath Antarctica's frozen surface. Beginning in the 1990s, ground-penetrating radar technology allowed scientists to map features hidden under miles of ice. What they found were subglacial lakes, mountain ranges, and formations that raised questions about what else might be buried. Ground-penetrating radar works by sending electromagnetic pulses into the ice. The pulses travel through frozen water at predictable speeds until they encounter something different: rock, liquid water, or air. When they hit these boundaries, they reflect back to surface receivers. By measuring the time delay and strength of return signals, scientists can build 3-dimensional maps of subsurface features. The technology can penetrate several miles of ice, though resolution decreases with depth. In Antarctica, GPR mounted on aircraft or dragged behind snow vehicles has transformed our understanding of what lies beneath the continent's frozen surface. The most famous discovery came in 1996, though hints existed earlier. Lake Vostok, buried beneath Russia's Vostok Research Station, is one of the world's largest lakes. It stretches approximately 160 miles long and 30 miles wide, with depths exceeding 1,600 feet. The lake sits beneath 2.5 miles of ice and has been isolated from the surface for potentially 15 million years. When confirmed through radar and seismic surveys, Lake Vostok proved that liquid water exists in large quantities beneath the Antarctic ice sheet, sealed in darkness and extreme pressure. Lake Vostok isn't alone. As radar mapping expanded, scientists discovered lake after lake: Lake Whillans, Lake Ellsworth, and over 400 others now documented. Some are small, barely a mile across. Others rival the Great Lakes in size. They exist because of geothermal heat from the Earth's interior and the insulating properties of thick ice above. The pressure from overlying ice lowers the freezing point of water, allowing it to remain liquid even at temperatures below 0 Celsius. These lakes form vast hidden networks, occasionally connected by rivers that flow beneath the ice sheet. But the discoveries weren't limited to lakes. Radar revealed mountain ranges that rival the Alps in scale, completely hidden beneath ice. Valleys deeper than the Grand Canyon, plains and basins and features that suggest Antarctica's bedrock topography is far more complex than the smooth ice surface above indicates. Some of these features appear in locations where their existence was never suspected. The radar signatures show not just elevation changes, but variations in density and composition that hint at geological diversity. Among the features detected, some have sparked debate. Radar returns occasionally show geometric patterns, anomalies that appear more regular than the chaotic signatures typical of natural geology, sharp angles where erosion should have created curves, linear features where randomness would be expected. Symmetrical arrangements that stand out in data otherwise dominated by irregular formations. Some researchers suggest these could indicate human construction, structures buried before the ice formed or tunneled into the ice itself. Others argue that volcanic features, ice dynamics, or data interpretation artifacts explain the patterns. Without direct observation, distinguishing between natural and artificial becomes a matter of interpretation. Imagine radar waves penetrating through ice, bouncing back from rock and water 2 miles below. Each return signal carrying information about hidden landscapes. The technology reveals a world beneath Antarctica as varied and complex as the visible surface of other continents. Mountains and valleys, lakes and rivers, all existing in perpetual darkness under pressures that would crush unprotected humans instantly. There are intriguing tidbits that emerge from radar surveys. Some subglacial lakes appear to drain and refill cyclically, suggesting dynamic water systems moving vast quantities of liquid beneath the ice. Certain radar anomalies near the pole have magnetic signatures that don't match surrounding geology. Mountain peaks detected beneath the ice sometimes show unexpectedly smooth surfaces, as if polished or worked, though glacial processes can produce similar effects. These details add texture to the picture of what lies below, but they also complicate interpretation. The challenge is coverage. Despite decades of radar surveys, only about 15% of Antarctica's subsurface has been mapped with high resolution. The continent is vast, nearly twice the size of Australia, and much of it remains too remote or too expensive to survey systematically. Technology improves each year with newer systems offering better penetration and resolution, but comprehensive mapping remains decades away. What we know represents a small sample of what exists beneath the ice. So beneath miles of ice, do these radar signatures show only natural geological features, ancient lakes and eroded valleys? Or could some represent structures too regular, too geometric to be explained by geology alone? The signatures are real, documented in scientific surveys conducted by institutions worldwide. Their interpretation, whether as marvels of natural processes or hints of something artificial, divides observers based on how they weigh evidence against the possibility. While radar probes the continent's depths, satellite imagery continues to reveal surface features, and among the most controversial are additional formations on the Antarctic Peninsula. that researchers describe as impossibly symmetrical. While radar probes the continent's depths, satellite imagery continues to reveal surface features. And among the most controversial are additional formations on the Antarctic Peninsula that researchers describe as impossibly symmetrical. At coordinates that have circulated among alternative researchers for years, peaks rise from the ice with angles that some say mirror architectural precision. Unlike the chaotic, jagged profiles of typical mountain ranges, these display what appears to be geometric regularity. The Antarctic Peninsula is the northernmost reach of the continent, extending towards South America like a crooked finger. It's also the most accessible region, where most research stations cluster and where tourist cruises venture during summer months. The climate is marginally less severe than the interior, and ice cover is thinner in places, allowing bedrock to protrude. These exposed peaks, called nunataks, are mountain summits that rise above the surrounding ice sheet. They're common throughout Antarctica, windows of rock breaking through the white expanse. What makes certain peninsular formations controversial is their shape. Several nunataks display pyramid-like geometry that appears too regular for natural processes. One formation near the tip of the peninsula shows 4 distinct faces converging at a sharp apex, with slopes that measure roughly 50 degrees, steep but within the range of both natural erosion and constructed pyramids. Another cluster of 3 peaks displays spacing that appears deliberate, each one similar in size and orientation. When viewed from certain angles via satellite, the symmetry is striking. Geologists have a ready explanation. Horn pyramids form when glaciers erode a mountain from multiple sides simultaneously. As ice flows around a peak, it carves circular depressions called cirques into the mountainside. When 3 or more cirques intersect, they leave a sharp, pyramid-shaped summit between them. The Matterhorn in Switzerland is the textbook example, a nearly perfect pyramid created entirely by glacial erosion over hundreds of thousands of years. The process is well understood. Given sufficient time and the right initial topography, glaciers sculpt rock into forms that can appear artificial to untrained observers. The angles matter. Glacial erosion typically produces slopes between 40 and 60 degrees, depending on rock type and erosion intensity. This range overlaps significantly with the angles found in constructed pyramids. Egypt's Great Pyramid has slopes of approximately 52 degrees. Mesoamerican pyramids vary but often fall within similar ranges, so an angle alone cannot distinguish natural from artificial. What geologists look for are other markers, tool marks, regularly spaced blocks, mortar lines, surfaces too smooth or too flat to be natural weathering. In satellite imagery of Antarctic formations, these markers are absent, or at least undetectable at current resolutions. But there are complications that keep debate alive. Some of the peninsular formations display unusually smooth faces for rock exposed to Antarctic winds. Others show alignments that appear to follow cardinal directions more consistently than random erosion would produce. The clustering of similar shapes in certain regions suggests either concentrated erosional processes or patterns worth investigating further. Without ground-level examination, distinguishing weathered construction from weathered geology remains difficult when both can produce superficially similar results. The formations exist. Satellite imagery confirms their pyramid-like geometry. The question is interpretation. Are these classic examples of horn pyramids, natural peaks sculpted by glaciers over millennia? Or do their proportions, their angles, and their clustering suggest something geology struggles to fully explain? Their evidence allows multiple readings. Academic geology sees familiar processes. Alternative researchers see anomalies worth closer examination. Both groups look at the same formations and reach different conclusions based on how they weight natural against artificial explanations. From the peaks themselves to the claims about them, we turn to the researchers and whistleblowers who assert that evidence of ancient structures has been found and subsequently suppressed. Their stories raise questions about what information reaches the public and what remains classified. From the peaks themselves to the claims about them, we turn to the researchers and whistleblowers who assert that evidence of ancient structures has been found and subsequently suppressed. Their stories raise questions about what information reaches the public and what remains classified. Over decades, accounts have emerged from individuals claiming knowledge of discoveries kept from public view, structures, artifacts, even entire complexes buried beneath the ice. The pattern of these claims is remarkably consistent, even when sources vary. They describe pyramid-shaped buildings, discovered during routine radar surveys, their dimensions too precise to be natural. They mention excavation sites established in remote interior locations, accessed only by military aircraft and staffed by personnel under strict confidentiality agreements. Some accounts describe artifacts recovered from these sites, objects displaying technology or craftsmanship that predates known human civilization. The specifics differ, but the core narrative remains similar across multiple testimonies. The motivations for suppression, according to these accounts, fall into several categories. Territorial claims provide one explanation. 7 nations maintain overlapping claims to portions of Antarctica. Discovery of ancient human habitation could complicate these claims under international law, creating incentives to keep findings quiet until political ramifications are sorted. Another cited reason is paradigm protection. Archaeological evidence of advanced civilization in Antarctica would require rewriting human history, contradicting established timelines and potentially undermining academic careers built on current models. A third explanation involves resources. If ancient sites exist, they might contain valuable artifacts or technology that nations want to secure before international treaties make them common heritage. Official responses to these claims have been consistent. Government agencies and research institutions deny suppression of archaeological discoveries. They point out that the Antarctic Treaty requires signatory nations to share scientific findings. Major discoveries would enhance a nation's prestige rather than damage it, creating incentive to publish rather than hide. The scientific community operates on peer review and replication, making sustained suppression of paradigm-shifting evidence practically impossible. Researchers from dozens of countries work at Antarctic stations. Coordination of a cover-up across competing national interests would require unprecedented cooperation for no clear benefit. The lack of corroborating physical evidence strengthens the skeptical position. No photographs have emerged from alleged excavation sites. No artifacts have been smuggled out by disgruntled researchers. No satellite imagery shows activity at locations where secret digs supposedly occurred. The accounts exist as testimony alone, uncorroborated by material proof. In contrast, legitimate Antarctic discoveries, meteorites containing evidence of Martian life, subglacial lakes, ancient climate data from ice cores, were announced promptly and studied openly. Yet the persistence of these accounts suggests something beyond simple fabrication. Some may represent misinterpretation of conventional research. Radar surveys of unusual geological features might be described as structures by non-specialists unfamiliar with what natural formations look like in radar data. Restricted military areas established for practical security reasons might be misunderstood as hiding archaeological sites. Information classified for legitimate national security purposes, submarine tracking data, surveillance capabilities, could be conflated with suppressed discoveries. The gap between what's publicly known and what exists in classified files creates space for speculation. There's also the possibility that some accounts are deliberate disinformation, stories planted to obscure actual classified activities unrelated to archaeology. During the Cold War, both superpowers maintained Antarctic presence, partly for strategic reasons. Spreading sensational stories about ancient pyramids could distract from mundane intelligence gathering or weapons testing. This wouldn't validate the pyramid claims, but it would explain why some accounts contain specific details that later prove false, a characteristic of disinformation designed to be eventually debunked, thereby discrediting all similar claims. So do these testimonies represent suppressed evidence of paradigm-shifting discoveries? Or do they reflect misinterpretations of conventional research amplified through retelling and filtered through expectations of conspiracy? Without access to the alleged evidence itself, we're left with accounts that exist in the grey space between verification and dismissal. They can neither be proven true without physical evidence nor completely dismissed without investigating every restricted Antarctic site. The pattern is intriguing. The proof remains absent. While testimonies vary in detail and credibility, one question remains constant across all claims. Could a civilization have existed in Antarctica within a time frame that would leave structures intact? And that brings us to the problematic timeline, the gap between Antarctic glaciation and human civilization. While testimonies vary in detail and credibility, one question remains constant across all claims. Could a civilization have existed in Antarctica within a time frame that would leave structures intact? And that brings us to the problematic timeline, the gap between Antarctic glaciation and human civilization. The Antarctic ice sheet began forming approximately 34 million years ago. The oldest known human civilizations emerged roughly 12,000 years ago. The gap between those dates is enormous, and it creates a fundamental problem for any theory of ancient Antarctic construction. Consider the numbers. 34 million years separates the formation of Antarctica's ice sheet from the present. During that span, the ice accumulated layer by layer, compressing under its own weight, flowing outward from the interior highlands, reshaping the continent beneath its mass. The ice is not a recent development. It predates the evolution of most modern mammal species. It's already ancient when our earliest human ancestors first appeared in Africa. Contrast that with human civilization. The archaeological record places the oldest monumental structures at roughly 11,500 years old. Göbekli Tepe in southeastern Turkey, with its massive T-shaped pillars and carved animal reliefs, represents the earliest known example of organized construction on a large scale. Before that, humans lived as mobile hunter-gatherers, leaving behind tools and campsites, but no pyramids, no cities, no evidence of the organizational capacity required for monumental architecture. Modern humans, Homo sapiens, evolved approximately 300,000 years ago, a time frame that sounds vast until measured against 34 million years. The entire span of human existence represents less than 1% of the time Antarctica has been frozen. The gap is 33,988,000 years, nearly 34 million years when Antarctica lay buried under ice while no human civilization existed anywhere on Earth to build structures there. For the Antarctic pyramids to be artificial, one of two scenarios must be true. Either human civilization is far older than any evidence indicates, extending back millions of years into a past where we have no archaeological record, no fossils of advanced hominids, no artifacts suggesting technological sophistication, or Antarctica's ice sheet is far younger than scientific consensus holds, having formed recently enough that humans could have built there before the continent froze. Evidence supporting the conventional timeline is extensive. Ice cores drilled from Antarctica's interior provide direct samples of accumulated ice stretching back hundreds of thousands of years. The Vostok core, extracted from the Russian research station of the same name, reaches back 420,000 years through continuous ice layers. Each layer represents a year of snowfall, compressed but intact. The deeper cores go, the older the ice, and the Vostok core barely scratches the surface of the ice sheet's total depth. Below the 420,000-year mark, ice continues for more than a mile, representing millions more years. Sediment cores taken from the ocean floor around Antarctica tell a complementary story. They show the transition from temperate conditions to glacial ones, preserved in layers of mud and rock deposited over millions of years. Pollen from Antarctic forests gives way to glacial sediment around 34 million years ago, marking the continent's transformation. Multiple independent dating methods, radiometric isotopes, magnetic signatures, fossil markers, all confirm the same timeline. Their ice is old, extraordinarily old, far older than human civilization. Alternative theories attempt to bridge this gap. Some propose that the ice sheet formed much more recently, perhaps within the last few thousand years, making Antarctica habitable when pyramid builders could have existed. These theories often invoke catastrophic pole shifts, rapid crustal displacement that would have moved Antarctica from a temperate latitude to its current polar position within human memory. Charles Hapgood popularized this idea in the 1950s, suggesting that the Earth's crust could shift across the mantle like a loose peel on an orange, relocating entire continents within centuries or even years. The scientific response is unambiguous. Crustal displacement on the scale Hapgood proposed contradicts fundamental physics. The energy required to move continental crust thousands of miles would be catastrophic beyond anything in the geological record. Magnetic pole wandering does occur, a well-documented phenomenon where the magnetic poles drift slowly across the planet's surface, but this involves Earth's magnetic field, not the physical crust. The two are separate processes. Magnetic poles can shift without moving continents, and even magnetic reversals, where north and south swap positions, take thousands of years to complete and leave clear signatures in volcanic rock worldwide. No evidence supports rapid crustal displacement within human timeframes. Imagine a timeline stretching from 34 million years ago to the present. At the far left, Antarctica begins to freeze. Across most of that line, through the age of mammals, through evolutionary diversification, through ice ages that came and went in the northern hemisphere, Antarctica remains frozen. Only at the very edge of the timeline, in the last tiny fraction, do humans appear. And only in the last microscopic sliver do pyramids emerge in Egypt, Mexico, and elsewhere. The scale makes coexistence between ice-free Antarctica and pyramid builders nearly impossible within conventional chronology. The conventional timeline creates what appears to be an impossible gap. For Antarctica to have hosted pyramid-building civilizations, either human history extends millions of years further back than any evidence suggests, or Antarctica's ice sheet is far younger than multiple lines of evidence indicate. Neither possibility fits current data, yet the pyramid-shaped peaks remain. They exist in satellite imagery, geometric and compelling, demanding explanation that the timeline makes extraordinarily difficult to provide. Yet some researchers point to a different scenario. Not that all of Antarctica was recently ice-free, but that changing sea levels during ice ages could have exposed coastal areas within human timeframes. And that leads us to examining how Ice Age geography might have created temporary windows of habitability. Yet some researchers point to a different scenario. Not that all of Antarctica was recently ice-free, but that changing sea levels during ice ages could have exposed coastal areas within human timeframes. And that leads us to examining how Ice Age geography might have created temporary windows of habitability. During the last glacial maximum, roughly 20,000 years ago, global sea levels dropped by approximately 400 feet. That dramatic change would have exposed significant portions of Antarctica's continental shelf, potentially creating habitable coastal zones, even while the interior remained frozen. The last glacial maximum, or LGM, occurred between roughly 26,500 and 19,000 years ago, when Earth's climate reached peak glaciation. Ice sheets covered much of North America and northern Europe. So much water was locked in ice that global sea levels fell dramatically compared to today. Reconstructions based on coral reefs, coastal sediment deposits, and ocean chemistry suggest a drop of 120 to 130 meters, approximately 400 feet below current levels. Coastlines extended far beyond their present positions. Land bridges appeared between continents, islands merged, and continental shelves that today lie submerged were exposed as dry land. Antarctica's continental shelf, the underwater platform surrounding the continent, varies in width. In some areas, it extends only a few miles from the current coast. In others, particularly along the Weddell and Ross Seas, the shelf stretches more than 300 miles. During the LGM, when sea levels dropped 400 feet, portions of this shelf would have been above water. The exposed areas wouldn't have been vast compared to the continent's total size, but they would have been significant, potentially tens of thousands of square miles of additional coastline. The theory proposes that these exposed coastal strips could have provided habitable zones, while the Antarctic interior remained buried under miles of ice. Coastal areas might have offered relatively milder conditions, access to marine resources, and stable ground for settlement or construction. If pyramid builders existed during this period, they could have worked on these margins, with their structures later submerged as sea levels rose at the end of the Ice Age or buried as ice advanced from the interior. But the hypothesis faces substantial challenges. Temperature is the most critical. Climate reconstructions for LGM Antarctica indicate conditions even colder than today. The interior may have been 10 to 15 degrees Celsius colder than present, which from a starting point of -50 to -60 degrees Celsius represents extreme cold even by Antarctic standards. Coastal areas would have been warmer than the interior, as they always are. But warmer is relative. Temperatures along exposed LGM coastlines likely remained well below freezing year-round, with winter extremes dropping to levels lethal without sophisticated shelter and heating. Human habitation of extreme cold environments provides some context. Indigenous Arctic peoples survived in regions with winter temperatures reaching -40 degrees Celsius, but they did so with specialized technology, insulated housing, tailored clothing, and reliable food sources from hunting and fishing. LGM Antarctic coasts would have been colder, darker for much of the year, and surrounded by even more hostile interior conditions. Marine resources might have existed, seals, penguins, fish, but harvesting them in perpetual near darkness during winter months would present extraordinary challenges. Archaeological precedent is also absent. No evidence of human habitation has been found at comparable latitudes in the southern hemisphere during the LGM. The southernmost human sites from that period are in southern South America, thousands of miles north of Antarctica, and in far milder climates. If humans reached exposed Antarctic coasts 20,000 years ago, they would represent the most extreme human adaptation to cold in all of prehistory, and no trace of that adaptation has been found. The geological possibility exists. Bathymetric maps show where Antarctica's shelf would have been exposed during low sea levels. Ancient shorelines, visible in some regions as raised beaches and coastal deposits, prove that sea levels were indeed lower. But exposed land doesn't equal habitable land. The Antarctic interior remained frozen. Glaciers flowed from the highlands to the coasts. Icebergs carved into surrounding seas. The exposed shelf areas would have been marginal zones between ice and ocean, cold, dark, and swept by katabatic winds that drain frigid air from the polar plateau. So could Ice Age. Sea level drops have created temporary coastal zones where structures were built before being submerged or buried as ice advanced. The geology allows for the possibility, but climate data suggests even exposed coasts would have been hostile to human habitation. And crucially, no archaeological evidence from such sites has been found. No tools, no campsites, no remains suggesting humans ever stood on Antarctica's Ice Age coasts. The theory provides a scenario that bridges the timeline problem, but it lacks the proof that would transform speculation into demonstrated history. From geological possibilities to the evidence itself, we turn to detailed analysis of what the satellite images actually show. How do professional geologists explain these formations? And what processes create pyramid-shaped mountains naturally? From geological possibilities to the evidence itself, we turn to detailed analysis of what the satellite images actually show. How do professional geologists explain these formations? And what processes create pyramid-shaped mountains naturally? Geologists point to well-understood processes that create pyramid-shaped peaks around the world. The Matterhorn in Switzerland, Amadablam in Nepal, K2 in Pakistan, all display sharp, symmetrical pyramid forms carved entirely by natural forces. The process is called glacial erosion, specifically the formation of horn pyramids or glacial horns. It begins with a mountain subjected to glaciation from multiple directions. Glaciers form in bowl-shaped depressions called cirques, carved into mountainsides by the freeze-thaw cycle and the grinding movement of ice. As glaciers flow outward from these cirques, they erode the rock through a combination of plucking, where ice freezes onto rock and tears pieces away, and abrasion, where rocks embedded in the glacier act like sandpaper against the bedrock. When 3 or more cirques form on different sides of the same mountain, they erode inward simultaneously. Each cirque cuts deeper into the mountain, creating steep walls. The ridges between adjacent cirques, called arêtes, become increasingly sharp as erosion removes material from both sides. Where multiple arêtes meet at the mountain's summit, they form a horn, a peak with distinct faces and sharp edges. The result is a pyramid-shaped mountain created entirely through erosion, with no human involvement whatsoever. The Matterhorn provides the classic example. Standing 14,692 feet tall on the border between Switzerland and Italy, it displays 4 distinct faces, aligned roughly with the cardinal directions. Each face is steep, angled between 45 and 60 degrees. The summit converges at a sharp point, visible from miles away. Geologists have studied its formation extensively. The Matterhorn's pyramid shape results from cirque glaciers that surrounded the mountain during the Pleistocene ice ages, carving it from a broader ridge into its current distinctive form. Over hundreds of thousands of years, the angles produced by glacial erosion fall within specific ranges. Cirque headwalls typically form at angles between 40 and 60 degrees, determined by the angle of repose for broken rock and the mechanics of ice movement. These angles overlap significantly with those found in human-built pyramids. Egypt's Great Pyramid displays slopes of approximately 52 degrees. Many Mesoamerican pyramids use angles between 45 and 55 degrees. The angle alone cannot distinguish natural from artificial. A pyramid-shaped mountain with 50-degree slopes could be either glacially carved rock or human construction. Additional evidence is needed. What would distinguish artificial structures from natural formations? Tool marks would be a key indicator, regular patterns of quarrying, cutting, or shaping visible in rock faces. Constructed pyramids show evidence of worked stone, blocks placed in courses, surfaces smoothed beyond what weathering produces naturally. They display regularity in spacing, in angles, in orientation that exceeds what erosion creates. Natural horn pyramids, despite their geometric appearance from a distance, show irregular surfaces up close, chaotic fracture patterns, variable weathering, and asymmetries that reveal erosional origin. Antarctic formations, viewed through satellite imagery, lack the resolution to show these distinguishing details. At the scale visible from orbit, both eroded mountains and the hypothetical constructed pyramids could appear similar. The geometry is clear. The angles can be measured approximately. But surface details, the presence or absence of worked stone, remain below the threshold of detection. Ground-level examination would be required to determine whether the rock faces show tool marks, whether the angles are too precise for natural processes, whether hidden features suggest construction rather than erosion. Geologists examining the satellite images of Antarctic peaks note characteristics consistent with horn pyramids. The formations appear in heavily glaciated regions where cirque formation is expected. They show the right scale, the right slopes, the right relationship to surrounding topography. Comparable formations exist throughout the world's glaciated mountain ranges. The Andes, the Himalayas, the Alps all contain peaks that from certain angles appear as perfect pyramids despite being entirely natural. Antarctica's extreme glaciation would produce such forms more commonly than in less glaciated regions. The geological explanation is robust and supported by countless examples worldwide. Glacial erosion creates pyramid-shaped peaks regularly and predictably. But does that account for all the Antarctic formations, particularly those with unusually precise proportions? Or do some display features that erosion patterns struggle to fully explain? The answer depends partly on what we consider unusual. Erosion can produce remarkable symmetry. Nature creates patterns that appear designed. The question is whether Antarctic formations exceed what we observe in known natural horn pyramids elsewhere, and whether that excess requires a different explanation. While geologists examine the rock itself, alternative researchers ask a different question. If these were artificial, what ancient culture could have possessed the capability to build them? And that takes us to theories of advanced civilizations predating recorded history. While geologists examine the rock itself, alternative researchers ask a different question. If these were artificial, what ancient culture could have possessed the capability to build them? And that takes us to theories of advanced civilizations predating recorded history. Some researchers propose that human civilization is far older and more sophisticated than mainstream archaeology acknowledges, suggesting advanced cultures existed during the last ice age or earlier, leaving traces we're only beginning to recognize. The lost civilization hypothesis takes several forms, but the core argument remains consistent. Mainstream archaeology places the emergence of complex societies around 5,000 to 6,000 years ago, with the first cities in Mesopotamia and Egypt. Before that, humans are understood to have lived as hunter-gatherers or simple agriculturalists, without the organizational capacity for monumental construction. Alternative researchers argue this timeline is incomplete, that evidence of earlier advanced societies has been overlooked, misinterpreted, or actively suppressed by academic institutions invested in current models. Proponents point to anomalies in the archaeological record, megalithic structures that appear older than their official dating, stoneworking techniques that seem too sophisticated for the cultures credited with their creation, similarities between distant civilizations that suggest contact or common origin, despite no known mechanism for such connections, and sites that continue to puzzle mainstream archaeologists, their purpose unclear, their construction methods debated, their age sometimes revised as new dating techniques become available. Göbekli Tepe in southeastern Turkey stands as the most compelling challenge to conventional timelines. Discovered in the 1990s and systematically excavated since, the site features massive T-shaped stone pillars arranged in circular enclosures. The pillars, some weighing 10 to 20 tons, are carved with elaborate animal reliefs: foxes, snakes, scorpion, vultures, radiocarbon dating places, construction at approximately 9,500 BC, making the site roughly 11,500 years old. That's 6,000 years before Stonehenge, before the pyramids of Egypt, before the emergence of agriculture and pottery in the region. Göbekli Tepe forces reconsideration of what early humans could accomplish. The site required quarrying, transporting, and erecting multi-ton stones. It required organized labor, hundreds or thousands of workers coordinated toward a common purpose. It required planning, architectural vision, and sustained effort over generations. Yet it predates all known cities, all known states, all known systems of writing that could have organized such projects. The builders were hunter-gatherers, yet they created something that looks like the work of a settled, hierarchical society. If this is possible 11,500 years ago, what else might early humans have achieved? Alternative researchers extrapolate from Göbekli Tepe to broader conclusions. If hunter-gatherers built sophisticated stone monuments in Turkey, could similar cultures have existed elsewhere, perhaps even in Antarctica, when climate permitted? The pyramid form appears across cultures: Egypt, Mesopotamia, Mesoamerica, Sudan, China, Indonesia. Each civilization developed pyramid construction independently according to mainstream archaeology, a case of convergent cultural evolution, driven by the pyramid's structural stability and symbolic power. Alternative theories propose a different explanation: a common source, a predecessor civilization that taught pyramid building techniques globally before being destroyed by catastrophe. Mainstream archaeology responds with multiple counter-arguments. Göbekli Tepe, while impressive, shows no evidence of being built by a technologically advanced civilization in the sense alternative theories propose. The tools found at the site are Stone Age implements, not advanced machinery. The construction techniques, while requiring organization, are within the capabilities of pre-agricultural societies, given sufficient motivation and time. And crucially, Göbekli Tepe is not alone. Other sites from the same period show similar sophistication: Karahan Tepe, also in Turkey, and various pre-pottery Neolithic settlements across the Fertile Crescent. These represent non-anomalies, but the previously underestimated capabilities of late hunter-gatherer societies, making the transition to agriculture. The evidence needed to prove a global Ice Age civilization would be substantial. Archaeologists would need to find multiple sites across different continents, clearly contemporary with each other and showing shared cultural features beyond basic architectural similarities. They would need artifacts displaying consistent technology spread across vast distances. They would need evidence of the population centers, the agricultural systems, the resource extraction that advanced civilizations require. A few anomalous sites and architectural similarities are not sufficient. The case requires comprehensive material culture preserved across the globe, something that, despite decades of searching, has not materialized. So did an advanced global civilization exist during the Ice Age, sophisticated enough to build monuments in Antarctica before the ice consumed them? Or does the apparent sophistication of ancient sites reflect independent human ingenuity rather than a lost golden age? The question divides researchers, with evidence marshaled on both sides, but consensus remaining elusive. Göbekli Tepe proves early humans were more capable than once believed. Whether that capability extended to Ice Age Antarctica is a question without archaeological support. From global theories to a specific legend, we turn to the most famous lost civilization of all, Atlantis. Could Plato's account describe a real place? And could Antarctica be its location? From global theories to a specific legend, we turn to the most famous lost civilization of all, Atlantis. Could Plato's account describe a real place? Could Antarctica be its location? In his dialogues, Timaeus and Critias, written around 360 BC, Plato described Atlantis as an advanced island civilization that sank into the sea. For centuries, scholars debated whether Atlantis was allegory or history. Some researchers now propose that Antarctica, before the ice, matches Plato's description. Plato's account comes through the character of Critias, who claims the story was passed down through his family from Solon, the Athenian lawgiver who lived 2 centuries earlier. According to Critias, Solon heard the tale from Egyptian priests during his travels. They told him of a powerful island nation that existed 9,000 years before Solon's time, placing Atlantis roughly 11,600 years ago if we take the dating literally. This civilization supposedly controlled territories beyond the Pillars of Hercules, the ancient name for the Strait of Gibraltar, suggesting a location in the Atlantic Ocean or beyond. The description is detailed. Atlantis was arranged in concentric rings of land and water, with a central island containing temples, palaces, and a harbour. The Atlanteans possessed advanced engineering, creating a sophisticated system of canals and bridges. They had abundant natural resources, access to precious metals, and a powerful military. Their reach extended across the Mediterranean, conquering parts of Europe and Africa until Athens, in a heroic defense, repelled their invasion. Shortly after their defeat, Atlantis was destroyed in a single day and night of catastrophic earthquakes and floods, sinking beneath the waves. Traditional attempts to locate Atlantis have focused on the Mediterranean and Atlantic. Santorini in Greece, devastated by a volcanic eruption around 1600 BC, is a popular candidate. The eruption destroyed the Minoan settlement at Akrotiri, creating a caldera that some argue inspired Plato's story. Others propose locations in the Atlantic near the Azores, Canary Islands, or even the Caribbean. Some theories place Atlantis in the North Sea, in Morocco, or in the Black Sea. Every proposed location requires adjusting either Plato's description or the physical evidence to make them match. The Antarctica-Atlantis connection relies primarily on the Piri Reis and other ancient maps that supposedly show the continent before ice. Proponents argue that beyond the Pillars of Hercules could mean the far southern hemisphere, technically beyond Gibraltar's line of sight. They note that Antarctica was indeed destroyed by a catastrophe, the onset of glaciation, and now lies beneath the sea of ice. The concentric ring structure described by Plato might represent misunderstood descriptions of Antarctic topography, coastal features distorted through millennia of retelling. But the problems with this identification are numerous. Plato's timeline places Atlantis 9,000 years before Solon, roughly 11,600 years ago. Antarctica was already frozen by that date, deeply into its glacial phase that began 34 million years earlier. The ice sheet was fully established, not forming. There's no evidence of habitable conditions when human civilizations could have built the advanced society Plato describes. Geography creates another issue. Plato describes Atlantis as larger than Libya and Asia combined, an enormous landmass. Antarctica is large, but his description suggests something even more vast. The concentric rings of land and water don't match Antarctica's actual topography, either current or reconstructed pre-ice. Then there's the question of Plato's intent. Most classical scholars interpret the Atlantis story as philosophical allegory rather than historical record. Plato was making a point about hubris, military overreach, and the dangers of imperial expansion. Athens, the virtuous city, defeats the corrupt empire. The story serves his philosophical arguments about ideal states and moral decline. Reading it as literal history may miss what Plato intended, a thought experiment, not a geography lesson. The level of detail doesn't necessarily indicate real events. Plato created detailed fictional dialogues throughout his works. Specificity served his rhetorical purposes. So could Antarctica be Plato's Atlantis, an advanced civilization submerged not by sea but by ice? The theory has its proponents, but it requires multiple assumptions unsupported by evidence. That Plato described a real place, that his timeline was accurate, and that Antarctica was ice-free when humans could have built there. Each assumption multiplies the improbability. Without archaeological evidence from Antarctica showing advanced civilization from the appropriate time period, the connection remains speculation built on interpreting ancient texts and ambiguous maps. Leaving behind Atlantis speculation, we turn to a real archaeological site that has transformed our understanding of early human capability. If humans built sophisticated structures 11,500 years ago, what else might they have achieved? Leaving behind Atlantis speculation, we turn to a real archaeological site that has transformed our understanding of early human capability. If humans built sophisticated structures 11,500 years ago, what else might they have achieved? In southeastern Turkey, on a hilltop called Göbekli Tepe, archaeologists uncovered massive stone pillars carved with intricate reliefs. The site dates to approximately 9,500 BC, 6,000 years before Stonehenge, before agriculture, before pottery. Its existence forces a re-evaluation of what early humans could accomplish. The discovery happened almost by accident. Local farmers knew the hill contained ancient stones, but assumed they were from a medieval cemetery. In 1994, German archaeologist Klaus Schmidt arrived to survey the site and immediately recognized its significance. Beneath the soil lay not gravestones, but megalithic architecture on a scale that shouldn't exist in the pre-pottery Neolithic period. Schmidt dedicated the rest of his life to excavating Göbekli Tepe, dying in 2014 with only a fraction of the site uncovered. Current estimates suggest only 5% has been excavated. The rest remains buried, waiting. What has been revealed is extraordinary. The site consists of multiple circular enclosures, each surrounded by T-shaped limestone pillars. These pillars stand 10 to 20 feet tall and weigh between 10 and 20 tons. They were quarried from limestone bedrock using stone tools, transported uphill to the site, and erected in carefully planned arrangements. The tops of the pillars form T-shapes, suggesting stylized human figures, perhaps ancestors or deities. Many are carved with elaborate animal reliefs, foxes stalking across the stone, snakes coiling around pillars, scorpions, vultures, wild boars, gazelles. The carving is sophisticated, showing understanding of proportion, perspective, and three-dimensional form. Radiocarbon dating of organic material at the site, charcoal, bone, consistently places the earliest construction phases around 9,500 BC. That's roughly 11,500 years ago, making Göbekli Tepe older than the pyramids of Egypt by 6,000 years, older than Stonehenge by 6,500 years, and predating the development of agriculture in the region by at least 500 years. The people who built this were hunter-gatherers. They had no cities, no writing, no metal tools, no domesticated animals beyond possibly dogs. Yet they created something that looks like the work of a complex, hierarchical civilization. The implications are profound. Building Göbekli Tepe required organization on a scale not previously attributed to pre-agricultural societies. Quarrying 20-ton pillars demands knowledge of stone properties, leverage, and coordinated effort. Transporting them to the hilltop requires planning, perhaps hundreds of workers pulling or rolling the stones using ropes and wooden rollers. Erecting them into precise circular arrangements requires engineering skill and architectural vision. Carving the detailed animal reliefs requires artistic capability and probably specialized craftsmen. And sustaining the project over decades or centuries requires feeding large labor forces, which suggests either abundant wild resources or early agricultural experimentation, not yet visible in the archaeological record. Göbekli Tepe also challenges assumptions about the relationship between agriculture and complex societies. The standard narrative held that agriculture came first, creating food surpluses that allowed people to settle permanently, develop social hierarchies, and invest labor in monumental construction. Göbekli Tepe reverses that sequence. The monument came first, built by mobile hunter-gatherers. Some archaeologists now propose that the need to feed workers building sites like Göbekli Tepe may have driven the development of agriculture, not the other way around. The monument didn't result from civilization. It may have caused it. There are fascinating details that deepen the mystery. The site shows no evidence of permanent habitation, no houses, no trash middens, no wells. People came to Göbekli Tepe for specific purposes, perhaps ritual gatherings or ceremonies, then left. The circular enclosures were deliberately buried after periods of use, filled with rubble and soil before new enclosures were built atop them. Why bury these elaborate structures? Was it ritual closure, purposeful decommissioning? The effort to bury them rivals the effort to build them, suggesting the act carried profound meaning. Animal bones found at the site: gazelle, aurochs, wild boar, show butchering marks and burning, evidence of feasting. Perhaps large groups gathered periodically for ceremonies that included communal meals. The scale of animal remains suggests feasts involving hundreds of people. Organizing such gatherings among mobile hunter-gatherer bands would require sophisticated social networks spanning large territories. Göbekli Tepe may represent not just an architectural achievement, but a social one, proof that complex organization predates settled life. Göbekli Tepe proves that humans 11,500 years ago were far more capable than once believed. If hunter-gatherers could quarry, transport, and erect 20-ton pillars, carving them with sophisticated imagery, what other achievements might have been possible? The site doesn't prove Antarctic pyramids, but it expands the window of plausibility for what early humans might have accomplished in other extreme environments. It demonstrates that complexity, organization, and monumental vision existed thousands of years before cities and writing, challenging us to reconsider what we think impossible for ancient peoples. From ancient human capabilities to modern political restrictions, we turn to the Antarctic Treaty and how it controls access to the continent. What are researchers allowed to explore, and what remains off-limits? From ancient human capabilities to modern political restrictions, we turn to the Antarctic Treaty and how it controls access to the continent. What are researchers allowed to explore, and what remains off-limits? Signed in 1959 by 12 nations during the height of the Cold War, the Antarctic Treaty established rules governing all activities on the continent. It designated Antarctica as a scientific preserve, banned military activity, and suspended territorial claims. But it also created a framework that some argue limits independent research and controls what information becomes public. The treaty emerged from a unique historical moment. By the late 1950s, 7 nations maintained territorial claims to portions of Antarctica: the United Kingdom, Norway, France, Australia, New Zealand, Chile, and Argentina. Some of these claims overlapped, creating potential for conflict. The United States and Soviet Union, while operating Antarctic research programs, refused to recognize any claims and reserved the right to make their own. With Cold War tensions escalating and nuclear testing spreading across the globe, Antarctica risked becoming another front in geopolitical competition. The solution was unprecedented. The 12 nations active in Antarctic research during the 1957-58 International Geophysical Year negotiated the treaty that suspended all territorial claims without requiring nations to relinquish them. No new claims could be made while the treaty remained in force. Military activity was prohibited except for personnel and equipment supporting scientific research. Nuclear testing and radioactive waste disposal were banned. And most importantly, the treaty committed signatories to free exchange of scientific information and international cooperation in research. The Antarctic Treaty entered into force in 1961 and has been remarkably successful by diplomatic standards. Territorial disputes were frozen without being resolved, allowing scientific cooperation to proceed without political interference. The original 12 signatories have grown to 54 parties representing most of the world's nations. The treaty has been supplemented by additional protocols, most notably the Protocol on Environmental Protection adopted in 1991, which designated Antarctica as a natural reserve devoted to peace and science and banned all mineral resource extraction indefinitely. How does the system actually work? Any nation wishing to conduct research in Antarctica must notify other treaty parties of their plans. Environmental impact assessments are required for all activities. Research stations must be open to inspection by other nations. Scientists from different countries regularly collaborate and share facilities. Data collected in Antarctica is supposed to be freely available to the international scientific community. The treaty created a model of international scientific cooperation that, on paper at least, prioritizes knowledge over national interest. But the system also creates restrictions. Access to Antarctica requires governmental approval and support. Independent expeditions face enormous logistical and financial barriers. Research stations are expensive to maintain, supplied by government-funded ships and aircraft. Getting permission to visit another nation's station or to conduct research in claimed territories involves diplomatic channels. Some areas are designated as specially protected for environmental reasons, restricting access even for scientists. These practical barriers mean that most Antarctic research happens through official channels, controlled by governments and academic institutions. This is where claims of suppression enter the picture. If paradigm-challenging discoveries were made, ancient structures, anomalous artifacts, evidence contradicting established history, would they be disclosed? The treaty requires sharing scientific information, but it doesn't specify what counts as scientific. Classification on national security grounds could remove information from the disclosure requirement. environmental protection could restrict access to sensitive sites, and the barrier to independent verification, the cost and logistics of reaching Antarctica, means that most people must accept official reports without ability to confirm them personally. Yet the treaty's actual text is public, available for anyone to read. The provisions are straightforward. The oversight mechanisms, inspections, multinational cooperation make sustained suppression difficult unless multiple nations coordinate to hide the same information. Every scientific discovery made in Antarctica, from meteorite finds to subglacial lake ecosystems to ice core climate data, has been published in international journals following standard academic protocols. The system may be imperfect, but it shows no obvious evidence of systematic suppression. So does the Antarctic Treaty enable international scientific cooperation while protecting a fragile environment? Or does it provide cover for restricting access to sensitive discoveries? The treaty text itself is public and straightforward, establishing environmental protections and research protocols that have prevented military conflict and environmental exploitation. The question is whether those protocols have been used to suppress paradigm-challenging findings, a claim that requires evidence beyond the restrictions themselves. Control exists. Whether that control has been used to hide archaeological discoveries remains unproven. Before the treaty, other nations had designs on Antarctica, and among the most controversial expeditions was Nazi Germany's 1938-39 mission to the continent, an operation that fuels speculation to this day. Before the treaty, other nations had designs on Antarctica, and among the most controversial expeditions was Nazi Germany's 1938-39 mission to the continent, an operation that fuels speculation to this day. In the austral summer of 1938-39, the German ship Schwabenland sailed to Antarctica under orders from Hermann Göring's Air Ministry. The vessel carried a crew of scientists, pilots, and sailors on what was officially described as a whaling reconnaissance and territorial claim mission. The expedition surveyed and photographed a region of Queen Maud Land that Germany subsequently named Neuschwabenland, or New Swabia. But the mission's activities, combined with Nazi interests in occult theories and advanced technology, have spawned decades of speculation about secret bases and hidden discoveries. The expedition was led by Captain Alfred Richer, an experienced polar explorer who had participated in earlier Arctic expeditions. The Schwabenland departed Hamburg in December 1938 and reached the Antarctic coast in mid-January 1939. Over the following weeks, the crew conducted extensive aerial photography using two Dornier-Wal flying boats, catapult-launched from the ship. The aircraft flew systematic survey patterns, photographing approximately 230,000 square miles of territory. During these flights, crews dropped small metal Nazi flags bearing swastika emblems at regular intervals, a symbolic claim of sovereignty over the territory below. The documented activities are straightforward. The expedition produced thousands of aerial photographs that revealed mountain ranges, glaciers, and coastal features previously unmapped. German cartographers used these photographs to create detailed maps of the region. The survey work was competent, even impressive, given the technology and conditions. Ships periodically approached the coast, where accessible, allowing limited ground observations and sample collection. After roughly 2 months of operations, the Schwabenland returned to Hamburg in April 1939. The mission was considered successful by its sponsors. achieving the stated objectives of mapping and territorial claim. This is where official history ends and speculation begins. Within years of Germany's defeat in World War II, stories emerged claiming the Neuschwabenland expedition had discovered more than just ice and rock. Some accounts suggested the mission found ice-free areas heated by volcanic activity, natural harbors sheltered from storms, even cave systems large enough to establish bases. Post-war conspiracy theories proposed that Nazi Germany constructed secret Antarctic facilities during or after the expedition, using them as refuges for escaping war criminals or as development sites for advanced weapons technology, including flying saucers based on supposed ancient designs or extraterrestrial contact. These theories gained traction, partly because of the mystery surrounding Nazi technological programs. Germany did develop remarkable weapons during the war: jet aircraft, ballistic missiles, advanced submarines. The idea that even more exotic projects existed in hidden facilities resonated with the documented reality of secret programs. Antarctica, remote and hostile, seemed a plausible location for activities requiring absolute secrecy. And the fact that some Nazi officials did escape to South America after the war, using rat lines through sympathetic networks, made the idea of Antarctic refugees seem less far-fetched than it might otherwise. But the evidence supporting these theories is thin. Post-war interrogations of German military and scientific personnel produced no mentions of Antarctic bases. Allied intelligence services, intensely interested in tracking Nazi war criminals and recovering advanced technology, found no documentation of such facilities. The logistics of constructing and maintaining Antarctic bases in the 1940s would have been extraordinary, requiring continuous supply shipments that Allied naval dominance would have made impossible during the war. And expeditions to the region after 1945, including Operation High Jump, found no evidence of German installations despite extensive aerial reconnaissance. The Neuschwabenland expedition fit into a broader context of 1930s polar exploration. Multiple nations were conducting Antarctic surveys during this period, driven by territorial ambitions, scientific interests, and national prestige. Britain, Norway, France, the United States, and others were all active in different regions of the continent. Germany's expedition was not unique in its activities or objectives. What makes it stand out is less the expedition itself than the mythology that developed around it afterward, fueled by Nazi mystique, wartime secrecy, and the enduring appeal of hidden history narratives. So did Nazi Germany establish secret bases in Antarctica, using the continent for advanced technology research? Or was the Neuschwabenland expedition a conventional territorial claim mission, later mythologized through the lens of Nazi mystique and post-war conspiracy theories? Official records document only surveying and photography, standard activities for polar expeditions of that era. The rest exists in speculation built on absence of evidence rather than evidence of presence, stories that fill gaps in documentation with assumptions about what might have been hidden. From historical expeditions to modern technology, we return to the tools that revealed the pyramid formations in the first place: satellite imaging. How do these systems work? And what are their limitations in identifying structures? From historical expeditions to modern technology, we return to the tools that revealed the pyramid formations in the first place: Satellite imaging. How do these systems work, and what are their limitations in identifying structures? Modern satellites can resolve objects as small as 1 meter from orbit hundreds of miles above Earth. Google Earth compiles imagery from multiple satellites, Landsat, Sentinel, commercial providers, creating detailed maps of even the most remote regions. Is this technology that revealed the Antarctic pyramids to researchers who would never set foot on the ice? Satellite imaging works by capturing light reflected from Earth's surface. Sensors aboard satellites detect electromagnetic radiation across various wavelengths: visible, light, infrared, sometimes radar. The data is transmitted to ground stations, processed into images, and compiled into maps. Resolution, the ability to distinguish small details, depends on several factors: the satellite's altitude, the quality of its sensors, and atmospheric conditions between the satellite and ground. High-resolution commercial satellites operate at lower altitudes and carry advanced optics, achieving resolutions approaching 0.5 meter per pixel. Government reconnaissance satellites are rumored to reach even higher resolutions, though exact capabilities remain classified. For Antarctica, several satellite systems provide coverage. Landsat, operated by NASA and the US Geological Survey, has been imaging Earth since 1972. Its resolution is moderate, about 30 meters per pixel, sufficient for mapping large features, but too coarse for detailed analysis. The European Space Agency's Sentinel satellites offer improved resolution and more frequent coverage, capturing the same area every few days. Commercial satellites like those operated by Maxar Technologies provide sub-meter resolution, allowing identification of objects smaller than a car. Google Earth aggregates imagery from these various sources, displaying the highest resolution data available for each location. Antarctica presents unique challenges for satellite imaging. Cloud cover, common in many regions, is less problematic over the ice sheet's interior, but affects coastal areas. More significant is the ice itself. Snow and ice reflect light intensely, creating glare that can saturate sensors. The low angle of sunlight at polar latitudes creates long shadows that obscure features while simultaneously revealing three-dimensional structure. In winter, months of darkness make optical imaging impossible, though radar satellites can penetrate clouds and operate in darkness by actively transmitting signals and measuring reflections. Distinguishing artificial structures from natural formations in satellite imagery is a developed skill in archaeology. Archaeologists use remote sensing to identify buried cities, ancient roads, and agricultural patterns invisible from ground level. Key indicators include geometric regularity, right angles, and parallel lines rare in nature, consistent orientation aligned with cardinal directions, and contextual features like nearby structures or roads suggesting human presence. Shadows reveal height and shape. Multispectral imaging detects material differences, showing where stone buildings contrast with surrounding soil or vegetation. These techniques have proven successful worldwide. In Egypt, satellite imagery reveals 17 lost pyramids beneath desert sand, confirmed through ground excavation. In Central America, LIDAR detected entire Maya cities hidden under jungle canopy. In Cambodia, archaeologists mapped the sprawling urban network surrounding Angkor Wat using radar that penetrated forest cover. The technology works when conditions allow proper analysis and when artificial structures display characteristics distinguishable from natural geology. But Antarctic ice complicates everything. Ice cover obscures subsurface features completely. Only peaks tall enough to protrude above the ice sheet are visible. The extreme environment means no vegetation patterns, no soil color changes, no infrastructure like roads that typically surround human settlements. Context: clues disappear. Shadows cast by steep mountains can look geometric depending on sun angle. Ice accumulation patterns can create lines and shapes that mimic artificial features. And without ground truthing, without physically visiting sites to examine rock surfaces for tool marks or construction evidence, satellite imagery alone cannot definitively prove whether formations are natural or artificial. So can satellite imagery definitively distinguish natural formations from artificial structures? In many contexts, yes. Archaeologists regularly identify ruins, roads, and building foundations from orbit using techniques refined over decades. But Antarctica's ice cover, extreme shadows, and lack of contextual features make identification more challenging. The pyramids show on satellite images, their geometric forms documented. But what they are, geological curiosities shaped by erosion or architectural wonders built before the ice, remains open to interpretation. The technology shows us the shapes. Determining their origin requires more than pixels on a screen, while satellites capture visible light and sometimes infrared. Another Antarctic mystery reveals itself in the visible spectrum. Bloodfalls, a feature that highlights how much we still don't understand about the frozen continent. While satellites capture visible light and sometimes infrared, another Antarctic mystery reveals itself in the visible spectrum. Bloodfalls, a feature that highlights how much we still don't understand about the frozen continent. At the edge of Taylor Glacier in the McMurdo Dry Valleys, a blood-red waterfall flows from the ice. Discovered in 1911 by geologist Griffith Taylor during Robert Falcon Scott's Terra Nova expedition, it appeared to be a geological impossibility. Liquid water flowing from a frozen glacier, stained deep crimson. Taylor initially attributed the color to red algae, a reasonable assumption given that microorganisms can survive in extreme environments and produce pigments. The hypothesis seemed to explain both the liquid water, metabolic heat from algae colonies, and the striking color. But as researchers studied the site more closely over subsequent decades, the algae theory collapsed. No viable algae populations could be found. The environment was too cold, too dark, too isolated. Something else was staining the water. The next theory focused on iron oxide, essentially rust. Perhaps ancient iron deposits in the rock were dissolving into meltwater, oxidizing as the water emerged into the oxygen-rich atmosphere. This explanation accounted for the red color without requiring living organisms. Iron oxide is common in rock, and oxidation reactions occur naturally wherever iron-bearing minerals meet water and air. The theory gained acceptance and appeared in scientific literature for decades. Bloodfalls was a chemical phenomenon, interesting but not extraordinary. Then in 2017, researchers finally solved the mystery. Using ground-penetrating radar and other techniques, they discovered what lies beneath Taylor Glacier, a subglacial lake of hypersaline brine, water so saturated with salt that it remains liquid even at temperatures well below 0 Celsius. The lake has been sealed beneath the glacier for potentially 2 million years, cut off from sunlight, from atmospheric oxygen, from any contact with the surface world. yet it supports life. The brine is roughly 3 times saltier than seawater and contains high concentrations of dissolved iron. When this water occasionally breaches the glacier through cracks and fissures, it flows down the ice face as blood falls. The iron, dissolved in the oxygen-free brine, oxidizes rapidly upon contact with air, creating the vivid red staining that gives the falls their name. The waterfall isn't blood. It's rust formation happening in real time as ancient, iron-rich water meets the atmosphere for the first time in millennia. What makes blood falls remarkable isn't just the chemistry, but the biology. Scientists analyzing the water discovered microorganisms thriving in conditions previously thought incompatible with life. These microbes survive without light, without oxygen, in water cold enough to freeze normal cells solid. They metabolize sulfur and iron compounds through chemosynthesis, extracting energy from chemical reactions rather than photosynthesis. They represent an entire ecosystem functioning in perpetual darkness under extreme pressure, sealed away from the rest of Earth's biosphere for millions of years. The discovery has implications far beyond Antarctica. If life can exist in Blood Fall's subglacial lake, sealed in darkness and extreme cold for 2 million years, what other hidden ecosystems might exist beneath the ice? Lake Vostok and the hundreds of other subglacial lakes detected by radar might harbor similar microbial communities, each one potentially unique, evolved in isolation for geological timescales. Some researchers suggest these environments serve as analogues for possible life on Europa or Enceladus, moons of Jupiter and Saturn, where subsurface oceans exist beneath thick ice shells. Picture the environment: a lake sealed in absolute darkness beneath thousands of feet of ice, water that should be frozen solid, kept liquid by pressure and salt, life eking out existence by processing minerals in the cold and the dark. It's an environment as hostile as any on Earth, yet life found a way. The microbes in Blood Falls survived not just thousands, but millions of years in conditions that would kill most organisms instantly. They adapted, evolved, persisted. Blood Falls proves that beneath Antarctica's ice, liquid water exists in sealed environments we're only beginning to explore. If microbes can survive for millions of years in brine lakes with no light, what else might exist in subglacial cavities? The discovery doesn't suggest ancient civilizations, but it demonstrates how much remains unknown beneath the ice. It shows that Antarctica's subsurface is active, complex, and capable of preserving features in conditions that seem impossible from the surface. From liquid water under glaciers to heat beneath the ice sheet, we turn to another force shaping Antarctica from below: volcanic activity that complicates the picture of what lies under the ice. From liquid water under glaciers to heat beneath the ice sheet, we turn to another force shaping Antarctica from below: volcanic activity that complicates the picture of what lies under the ice. Antarctica isn't frozen solid all the way down. Beneath the ice, active and dormant volcanoes dot the landscape, producing heat, creating cavities, and generating anomalies that radar and thermal imaging detect. Mount Erebus, standing 12,448 feet tall on Ross Island, is the world's southernmost active volcano. It erupts continuously, maintaining a persistent lava lake at its summit that has been active for decades. Mount Erebus is visible, dramatic, well-studied, but is only the most obvious manifestation of Antarctic volcanism. In 2017, researchers from the University of Edinburgh published findings that transformed understanding of the continent's volcanic landscape. Using radar data and seismic surveys, they identified 138 previously unknown volcanic cones beneath the West Antarctic ice sheet. These volcanoes, buried under ice, range from small cones a few hundred feet tall to peaks approaching 13,000 feet, comparable to Mount Erebus itself. Most appear dormant, but some show signs of geothermal activity that affects the ice above them. The discovery more than doubled the known number of volcanoes in Antarctica. It revealed that the West Antarctic Rift System, a zone of crustal extensions similar to East Africa's rift valleys, is far more volcanically active than previously understood. The rift stretches for thousands of miles beneath the ice, representing a fundamental tectonic boundary where the continent is slowly being pulled apart. This tectonic activity generates magma that rises toward the surface, creating volcanoes that remain hidden beneath the ice sheet. Volcanic heat affects everything above it. Where magma chambers sit close to the bedrock surface, geothermal heat melts ice from below, creating subglacial lakes and water systems that flow beneath the glacier. These meltwater networks lubricate the ice sheet's base, affecting how glaciers flow toward the ocean. Some of the rapid ice loss observed in West Antarctica may be driven partly by volcanic heat, destabilizing ice from beneath. Though climate warming remains the dominant factor, the interaction between ice and volcanism creates complex feedback systems that scientists are only beginning to understand. Volcanic structures themselves can display geometric forms that might be mistaken for artificial construction. Volcanic cones, especially cinder cones and stratovolcanoes, often show remarkable symmetry. They form as material erupts from a central vent, building up in layers that radiate outward evenly. The result can be a near-perfect cone shape, with slopes determined by the angle of repose for volcanic material, typically between 30 and 40 degrees. From certain angles, particularly when partially buried or eroded, volcanic cones can resemble pyramids. There are intriguing details that add complexity. Some Antarctic volcanoes show unusually smooth surfaces where ice has polished their flanks. Others display alignments, chains of volcanic vents following rift structures that from above appear geometric rather than random. Thermal anomalies detected by satellite sometimes occur in clusters that suggest organized patterns, though these reflect underlying tectonic structures rather than artificial arrangement. And volcanic peaks protruding through ice, particularly in regions like Marie Byrd Land, where volcanism is concentrated, show shapes and spacing that alternative researchers find suspicious. So could some pyramid-shaped formations be volcanic cones, rather than erosional peaks or artificial structures? Volcanic cones can display remarkable symmetry, and Antarctic volcanism is more extensive than once thought. It adds another natural explanation to consider, though it doesn't account for all reported formations. The Ellsworth Mountains, where the most discussed pyramid peaks are located, sit far from known volcanic zones. They're part of an ancient mountain range formed by tectonic collision, not volcanic activity. Volcanic explanations work for some regions, but not others, leaving the question partially answered at best. From geological heat to cosmic alignments, we turn to claims that some Antarctic formations align with astronomical phenomena, arguments that pyramid builders worldwide incorporated celestial knowledge into their constructions. From geological heat to cosmic alignments, we turn to claims that some Antarctic formations align with astronomical phenomena, arguments that pyramid builders worldwide incorporated celestial knowledge into their constructions. The Great Pyramid of Giza aligns to true north with remarkable precision, its deviation less than 3/60ths of a degree. The pyramids of Teotihuacan in Mexico mirror the constellation Orion's Belt, according to some researchers. From Egypt to Mexico to Cambodia, ancient builders oriented their monuments to celestial events, solstices, equinoxes, stellar risings. Some researchers argue that if Antarctic peaks are artificial, they should show similar astronomical alignments. The evidence for celestial orientation in ancient architecture is compelling across multiple cultures. Giza's alignment to cardinal directions, achieved without magnetic compasses or modern surveying equipment, demonstrates sophisticated astronomical knowledge. The builders likely used the stars, observing circumpolar stars that never set, tracking their rotation around the celestial pole to establish true north. The precision achieved within a fraction of a degree required careful observation over extended periods and mathematical understanding to convert observations into architectural practice. Angkor Wat in Cambodia aligns precisely with the spring equinox. Stand at the western gate on that day, and the sun rises directly over the temple's central tower. This wasn't accident, but deliberate design, connecting the structure to cosmic cycles. The temple's layout incorporates astronomical symbolism throughout, with measurements and proportions reflecting lunar and solar calendars. Many other temples at Angkor show similar orientations, suggesting systematic incorporation of astronomical knowledge into sacred architecture. Teotihuacan's alignment is more controversial, but still compelling. The city's main avenue, the Avenue of the Dead, orients roughly 15 degrees east of north. Some researchers argue this angle aligns with the setting of the Pleiades star cluster, significant in Mesoamerican cosmology. The three main pyramids, Pyramid of the Sun, Pyramid of the Moon, and Temple of the Feathered Serpent, are positioned along this axis in proportions that some claim mirror Orion's belt stars. Mainstream archaeologists dispute the Orion correlation, noting that many star patterns could be found to match if you allow sufficient flexibility in interpretation. What would astronomical alignments prove? If Antarctic peaks displayed precise orientation to cardinal directions, alignments with solstice sunrise or sunset angles, or positioning that mirrors significant star patterns, it would suggest intentional design. Natural mountains can face any direction randomly. Finding statistical clustering of orientations toward astronomically significant angles would exceed what chance produces. It would indicate that whoever positioned these structures possessed astronomical knowledge and considered it important enough to incorporate into construction. But testing alignment claims for Antarctic formations faces substantial obstacles. The peaks sit on a continent that has drifted significantly over millions of years. Plate tectonics slowly move continents across Earth's surface. Antarctica's current position at the South Pole is geologically recent, and the continent has rotated as it moved. Any structures built when Antarctica was elsewhere would have shifted orientation as the continent drifted. Determining original alignment requires reconstructing the continent's position at the time of construction, a calculation that depends on knowing when construction occurred. Ice movement creates another complication. The Antarctic ice sheet flows outward from interior highlands toward the coasts. Anything sitting on or within the ice would be carried along, potentially rotating and shifting from original positions. Even structures built on bedrock could be surrounded by moving ice that obscures their base, making it impossible to determine true orientation. And satellite imagery from directly overhead doesn't easily reveal orientation. Precise measurements require known reference points and careful surveying, difficult to achieve remotely. Some researchers have analyzed available satellite data for orientation patterns. Certain formations do show faces aligned roughly north-south or east-west. Whether this is significant depends on how many formations you examine and how precisely aligned they need to be to count as non-random. With enough formations measured loosely enough, some will appear aligned by chance. Rigorous statistical analysis would be required, comparing observed orientations against what random mountain peaks typically show. Such analysis has not been published in peer-reviewed literature for Antarctic formations. So if the Antarctic peaks were artificial, would they show astronomical alignments like pyramids elsewhere? The question assumes we could determine original orientations despite millions of years of continental drift and ice shifting. Current satellite data shows some formations oriented along roughly north-south lines, but whether that's significant or coincidental requires more data than is currently available. The alignments that make Giza, Angkor, and Teotihuacan impressive involve precision measurements made at ground level. Without that level of survey data from Antarctica, alignment claims remain speculative. From astronomical arguments to the researcher who brought many of these theories into mainstream discussion, we turn to Graham Hancock and the controversial hypothesis that has both energized alternative archaeology and drawn criticism from the academic establishment. From astronomical arguments to the researcher who brought many of these theories into mainstream discussion, we turn to Graham Hancock and the controversial hypothesis that has both energized alternative archaeology and drawn criticism from the academic establishment. Graham Hancock, journalist and author of books like Fingerprints of the Gods and Magicians of the Gods, proposes that an advanced civilization existed during the last ice age, building monuments around the world before being destroyed by cataclysm around 12,800 years ago. Antarctica, he suggests, might have been one of their centers. Hancock's background is journalism, not academic archaeology. He worked as East Africa correspondent for The Economist in the early 1980s before turning to writing books that challenge conventional historical timelines. This outsider status matters in how his work is received. He's not bound by academic peer review or institutional constraints, allowing him to propose theories that credentialed archaeologists might avoid for career reasons. But it also means his work doesn't undergo the rigorous vetting that academic research requires, a point critics emphasize when dismissing his conclusions. The core of Hancock's hypothesis centers on the Younger Dryas period, a dramatic climate event that began approximately 12,800 years ago. Global temperatures plummeted suddenly, glaciers advanced, and megafauna extinctions accelerated. The cause remains debated, but one theory proposes a comet impact or airburst that triggered the cooling and potentially devastated human populations. Hancock suggests that before this catastrophe, an advanced civilization existed, building monuments and spreading knowledge globally. The cataclysm destroyed most traces, but survivors carried fragments of their culture to various regions, teaching architecture, astronomy, and agriculture to hunter-gatherer populations they encountered. Evidence Hancock sites include sites like Göbekli Tepe, which predates agriculture and demonstrates sophisticated construction capabilities earlier than mainstream archaeology predicted. He points to the Sphinx, arguing that water erosion patterns on its enclosure suggest construction millennia before the conventionally accepted date of 2500 BC, when Egypt's climate was wetter. Ancient maps like those of Piri and Orontius Phineus are presented as copies of older source maps made when Antarctica was ice-free. Similarities between distant pyramid-building cultures suggest common origin rather than independent invention. Mathematical constants encoded in monument proportions, such as pi and phi in Giza's dimensions, indicate advanced knowledge. Antarctica plays a specific role in Hancock's framework. He proposes that the continent, positioned further from the pole before crustal displacement, shifted it southward, served as a homeland for this lost civilization. When catastrophe struck and ice advanced, survivors migrated outward, settling in places that became Egypt, Mesopotamia, India, and Mesoamerica. The pyramid forms found globally represent architectural knowledge carried from Antarctic origins. The ancient maps showing ice-free coastlines are remnants of cartographic surveys made before the ice formed. If true, Antarctic pyramids would be the source, with later pyramids worldwide being copies built by civilizations taught by Antarctic refugees. Academic archaeologists respond with multiple critiques. The geological evidence for crustal displacement on the timescale required doesn't exist. Ice core data confirms Antarctica has been frozen for 34 million years, not thousands. The sites Hancock cites as anomalous have conventional explanations within standard archaeology. Göbekli Tepe, while impressive, shows Stone Age construction techniques, not advanced technology. Sphinx erosion patterns are disputed, with most geologists supporting traditional weathering explanations. The mathematical constants in pyramids can be products of the construction methods used rather than encoded knowledge, and most fundamentally, no material culture exists showing the advanced civilization Hancock proposes. Where are their cities, their metallurgy, their remains? The standard for extraordinary claims, scientists emphasize, is extraordinary evidence. Proposing a globe-spanning advanced civilization destroyed by cataclysm requires finding consistent artifacts across continents, technology clearly beyond Stone Age capabilities, remains of population centers, evidence of the catastrophic destruction. A few anomalous sites and architectural similarities don't meet that threshold. Archaeology deals in material culture, physical objects that can be dated, analyzed, and tested. Without that, theories remain speculation regardless of how compelling the narrative. Yet Hancock's work resonates with millions of readers and viewers. His Netflix series, Ancient Apocalypse, reached global audiences, sparking renewed interest in alternative history. The appeal isn't difficult to understand. His theory offers a more dramatic human story than gradual cultural evolution. It suggests that ancient peoples were as sophisticated as moderns, separated by knowledge lost rather than intelligence gained. It challenges academic authority, appealing to those who distrust institutional narratives, and it leaves room for wonder, for the possibility that major discoveries still await beneath ice, jungle, or desert. The debate also highlights different standards of evidence. Hancock operates in popular media, where compelling narrative and suggestive correlations engage audiences. Academic archaeology requires reproducible findings, statistical rigor, and peer review. Both sides talk past each other, one demanding definitive proof, the other pointing to anomalies that deserve investigation. The truth likely lies in recognizing that archaeology constantly revises based on new evidence. Göbekli Tepe did force reconsideration of Neolithic capabilities, while also maintaining standards for what constitutes proof versus intriguing speculation. So does Hancock's hypothesis explain the Antarctic pyramids as remnants of a lost Ice Age civilization destroyed by cosmic catastrophe? Or does it weave together disparate anomalies without the rigorous evidence archaeology demands? The theory remains controversial, compelling to many but unproven by academic standards. What it does accomplish is keeping questions open about human capabilities in the deep past, about what might lie undiscovered beneath ice sheets and jungles, about whether our timeline of civilization is as complete as we assume. Whether those questions lead to paradigm-shifting discoveries or simply engage public imagination remains to be determined. While Hancock's work exists outside academic archaeology, mainstream science has its own response to pyramid claims. That brings us to the detailed academic rebuttals explaining why the Antarctic formations are almost certainly natural. While Hancock's work exists outside academic archaeology, mainstream science has its own response to pyramid claims. And that brings us to the detailed academic rebuttals explaining why the Antarctic formations are almost certainly natural. Professional geologists examining the satellite imagery see textbook examples of horn pyramids, peaks carved by glacial erosion from multiple sides. The angles, the proportions, the clustering, all consistent with natural geological processes understood for more than a century. Academic consensus is clear. These are mountains, not monuments. The geological explanation begins with observation. When geologists analyze the Antarctic formations, they compare them to thousands of known natural peaks worldwide that display similar geometry. The Matterhorn, Mount Assiniboine in Canada, Alpamayo in Peru, Amadablam in Nepal, all show pyramid shapes created entirely through erosion. These aren't isolated examples, but common features in heavily glaciated mountain ranges. The process is reproducible, predictable, and leaves characteristic signatures that geologists can identify. What distinguishes artificial structures from natural formations? Archaeologists and geologists have developed clear criteria through decades of fieldwork. Artificial construction shows regularity in coursing, visible blocks or stones arranged in layers. Tool marks appear on surfaces where stone was quarried or shaped. Right angles and parallel lines emerge at scales nature rarely produces through random erosion. Materials often differ from surrounding geology, having been transported from quarries. Foundations, thresholds, and architectural details like doorways, windows, or interior chambers provide unmistakable evidence of human work. Natural formations, even when geometrically impressive, lack these markers. Horn pyramids display irregular surfaces up close, with fracture patterns following rock weaknesses, rather than artificial planes. Weathering creates texture inconsistent with worked stone. Asymmetries become apparent from different viewing angles, revealing that the pyramid shape is perspective dependent rather than truly geometric. And crucially, natural peaks fit into their geological context, sitting atop mountain ranges formed by tectonic processes composed of rock matching surrounding formations. The Antarctic peaks, at the resolution available through satellite imagery, show none of the distinguishing features of artificial construction. They appear where geological processes predict mountain formation. Their rock appears consistent with ancient mountain ranges formed by continental collision. Their arrangement follows topographic logic rather than planned layout. The pyramid shapes emerge from specific viewing angles and lighting conditions, but show irregularities that natural erosion produces. From the evidence available remotely, they match expectations for glacially eroded peaks in ancient mountain ranges. This doesn't mean geologists dismiss the formations as uninteresting. Antarctica's geology is complex and not fully mapped. Unusual. Erosion patterns, unexpected rock types, or features requiring new geological explanations could exist and would merit study. Science advances by investigating anomalies, but investigation requires distinguishing between unusual and worth studying versus inconsistent with natural processes and requiring alternative explanations. The Antarctic peaks fall into the former category, interesting geology, not the latter, evidence contradicting known processes. What would change scientific consensus? Clear evidence that couldn't be explained geologically, ground-level examination revealing tool marks, work surfaces, or construction features, materials analysis showing transported stones rather than natural bedrock, internal structures visible through improved radar, chambers or passages inconsistent with natural caves, artifacts recovered from the sites, tools, carvings, anything indicating human presence, or mathematical analysis proving that the formation's proportions exceed what natural processes produce statistically. Any of these would force re-evaluation. Their absence keeps the geological explanation dominant. The debate reveals a fundamental tension about evidence thresholds. How much evidence is required to overturn conventional explanations? Science demands reproducible, testable data that survives peer review. A few satellite images showing geometric shapes without ground verification, without artifacts, without anything beyond resemblance to artificial structures, don't meet that standard. Resemblance alone isn't proof. Nature produces geometric forms regularly. Crystals form perfect shapes. Basalt columns create hexagonal patterns. Erosion sculpts arches and bridges. Seeing human design in natural patterns is a tendency called pareidolia, seeing faces in clouds, or patterns in randomness. Science requires more than pattern recognition to establish artificial origin. So from academic geology's perspective, the Antarctic pyramids are solved, natural formations explained by well-understood erosional processes. But the debate reveals a deeper tension. How much evidence is required to overturn conventional explanations? Science demands reproducible, testable data. Without that, formations that merely look artificial remain geological curiosities, however compelling they may appear. The shapes exist, documented in satellite imagery. Their origin, whether carved by ice over millennia or constructed by unknown builders, depends on evidence that current remote observations cannot provide. From visible light satellite imagery to thermal detection, we turn to another technology, revealing Antarctic secrets, infrared imaging that shows heat signatures beneath the ice. From visible light satellite imagery to thermal detection, we turn to another technology revealing Antarctic secrets: infrared imaging that shows heat signatures beneath the ice. Thermal satellites measure infrared radiation, detecting temperature differences invisible to optical cameras. In Antarctica, they've revealed unexpected warm spots, areas where heat appears to rise through the ice, creating signatures that some researchers find difficult to explain through volcanism alone. Thermal imaging works by detecting electromagnetic radiation in the infrared spectrum, wavelengths longer than visible light that all objects emit based on their temperature. Satellites equipped with thermal sensors, including MODIS aboard NASA's Terra and Aqua satellites, and the ASTER instrument, scan Earth's surface measuring these emissions. The data translates into temperature maps showing heat distribution. Over ice sheets, the technology can detect temperature variations of just a few degrees, revealing where heat escapes from below. Antarctica generates heat from several known sources. Volcanic activity, as discussed earlier, produces localized hotspots. Mount Erebus shows a clear thermal signature visible from space, its active lava lake radiating heat that melts surrounding ice. The 138 subglacial volcanoes discovered in West Antarctica, many showing geothermal activity, create additional heat sources. Geothermal gradients, a natural increase in temperature with depth toward Earth's hot interior, generate background warmth that affects ice dynamics. In regions with thinner crust or active tectonic processes, geothermal heat flux can be substantial. These expected heat sources account for most thermal anomalies detected. Mount Erebus is obvious and explained. Other volcanic areas show signatures consistent with magma chambers or hydrothermal activity. Geothermal modeling predicts certain regions should display elevated temperatures, and thermal imaging confirms those predictions. The correlation between known geological activity and detected heat signatures strengthens confidence that natural processes explain what satellites observe. But not all thermal anomalies map neatly to known volcanoes or predicted geothermal activity. Some appear in regions where no volcanic structures have been identified. Others show heat distributions that don't match typical volcanic profiles, which concentrate at central vents and dissipate outward in predictable patterns. A few display geometric arrangements, multiple hotspots spaced at regular intervals that catch attention. Whether these represent undiscovered geological features or something else divides interpretation. Geologists offer straightforward explanations. Antarctica's subsurface is incompletely mapped. Discovering 138 previously unknown volcanoes in 2017 proved how much remains undocumented. Heat signatures not matching known features likely indicate volcanic or geothermal activity, not yet catalogued, rather than artificial heat sources. Geological surveys using limited data points may miss features visible in comprehensive thermal imaging. As mapping improves, anomalies resolve into natural phenomena. The process of discovery necessarily involves periods where observations outpace explanation, but that gap closes as knowledge accumulates. Alternative researchers note that artificial heat sources would create thermal signatures. Bases, power generation, enclosed habitats, any human activity in extreme cold requires heating that would show in infrared imaging. Structures exist beneath ice with active heating or residual warmth from construction or occupation. Thermal satellites could potentially detect them. The question becomes whether detected anomalies exceed what natural processes produce, and whether their distribution suggests design rather than random geological occurrence. Distinguishing between natural and artificial heat requires more than detecting warm spots. Pattern analysis matters. Do hotspots cluster in ways natural geology predicts? Or do they show spacing and arrangements suggesting planning? Intensity profiles differ between volcanic heat, which peaks sharply at vents, and distributed heating from artificial sources. Time series data, showing stability or change in thermal signatures, helps identify sources. Volcanic systems fluctuate as magma moves. Geothermal heat remains relatively constant. Artificial sources might show cycles or sudden changes inconsistent with geology. So, do thermal anomalies indicate hidden artificial structures generating heat? Or do they reveal a geothermally active continent still being mapped, with hotspots marking volcanic features not yet fully catalogued? The signatures are real, documented by satellite systems. Their source, volcanic, geothermal, or something else, remains a matter of interpretation and further investigation. Heat exists beneath Antarctic ice. What generates that heat in every case is the question thermal imaging alone cannot definitively answer. While modern satellites reveal Antarctic mysteries, historical maps suggest knowledge of the continent long before its official discovery. And that brings us back to cartographic puzzles, the Orontius-Phineas map of 1531. While modern satellites reveal Antarctic mysteries, historical maps suggest knowledge of the continent long before its official discovery. And that brings us back to cartographic puzzles, the Orontius-Phineas map of 1531. Created by French mathematician and cartographer Orontius-Phineas, this world map depicts a large southern continent labeled Terra Australis. The continent's shape bears striking resemblance to Antarctica, complete with bays, peninsulas, and interior features that weren't supposed to be known until the 19th century. Charles Hapgood, examining the map in the 1960s, argued it showed Antarctica without ice, mapped by an unknown ancient civilization. Orontius-Phineas was a respected figure in 16th century France, a mathematician and cartographer who taught at the Collège Royal in Paris. His 1531 world map was part of broader efforts during the Renaissance to compile geographic knowledge from classical sources and contemporary exploration. The map itself is a heart-shaped projection, a popular style of the era, showing the known world with decorative flourishes and Latin inscriptions describing various regions. The southern continent occupies the bottom portion, labeled Terra Australis, Recenta, Inventa, Sed Nondum, Plene Cognita. Southern land recently discovered but not yet fully known. What catches attention is the detail. The continent shows mountains along what would be Antarctica's transantarctic range. Rivers flow from interior highlands toward coasts. Bays and inlets cut into coastlines at positions that roughly correspond to features of the actual Antarctic coast. The overall shape, while distorted by the projection and artistic interpretation, resembles Antarctica more than any random landmass should. When Hapgood overlaid the map onto modern projections of Antarctica, he found correlations he considered too precise to be coincidental. Hapgood's analysis, published in Maps of the Ancient Sea Kings, proposed that Phineas had copied from much older source maps, perhaps dating back thousands of years to when Antarctica was ice-free. He pointed to specific features, the Ross Sea appearing as a bay where it exists in reality, the Antarctic Peninsula extending northward as shown on the map. Mountainous terrain marked in the interior, where the Transantarctic Mountains actually lie beneath ice. These correlations, Hapgood argued, exceeded what Renaissance speculation could produce. Phineas must have been working from genuine geographic knowledge preserved from antiquity. Mainstream cartographers and historians offered different interpretations. They emphasized that Terra Australis was a theoretical construct inherited from ancient Greek geography. Ptolemy and other classical geographers proposed that a large southern landmass must exist to balance the continents of the northern hemisphere. This wasn't based on exploration, but on symmetry and balance, concepts central to ancient cosmological thinking. Medieval and Renaissance mapmakers perpetuated this tradition, drawing southern continents based on theory rather than observation. The tradition of Terra Australis meant that virtually every world map from the 15th through 17th centuries showed a southern continent. Mapmakers had creative license to fill in details based on speculation, rumor, and artistic interpretation. Some showed Terra Australis as a narrow band, others depicted it as vast, dwarfing known landmasses. Features like mountains, rivers, and bays were added to make maps visually complete and impressive, not because cartographers had surveyed them. The maps were as much art as science, blending observed data with theoretical geography and decorative elements. When measured precisely, the Phineas map's accuracy is mixed. Some coastal features do align with Antarctica's actual geography, but many don't. The continent's size is exaggerated. The shape is distorted beyond what projection alone explains. Rivers shown in the interior don't match any known Antarctic topography, though they could represent features that exist beneath ice. Mountains appear in some correct locations, but are absent where they should be and present where they shouldn't. The overall correlation, while intriguing at first glance, breaks down under detailed analysis. If Phineas was copying accurate ancient maps, why are there so many errors? Contemporary maps from the same era show similar southern continents with comparable detail. The Waldseemüller map of 1507, the Schöner globe of 1515, various Portuguese and Italian charts, all depicted Terra Australis with rivers, mountains, and coastal features. This pattern suggests a shared cartographic tradition, rather than independent access to ancient accurate sources. Mapmakers copied from each other, embellishing and interpreting as they went. The similarities between their southern continents reflect common sources and shared conventions, not ancient geographic knowledge. So did Orontes Phineas copy from ancient maps showing pre-ice Antarctica? Or did he extrapolate a hypothetical southern continent following the geographic theories of his time? The resemblance is striking in some areas, wildly inaccurate in others. The map fascinates but doesn't prove. It sits in that ambiguous space between tantalizing hint and historical curiosity, showing enough correlation to fuel speculation, but enough error to justify dismissal. Like the Peary race map before it, the Phineas map raises questions about Renaissance cartographic sources without providing definitive answers. From ancient maps to modern politics, Antarctica's value isn't only scientific or historical, it's also economic. Beneath the ice lie vast mineral resources, and that brings us to the geopolitical tensions surrounding the frozen continent. From ancient maps to modern politics, Antarctica's value isn't only scientific or historical, it's also economic. Beneath the ice lie vast mineral resources, and that brings us to the geopolitical tensions surrounding the frozen continent. Geological surveys suggest Antarctica contains significant deposits of coal, iron ore, copper, gold, and potentially oil and natural gas. 7 nations maintain territorial claims that overlap in places. The Antarctic Treaty forbids mineral exploitation, but that ban faces review in 2048, creating a looming deadline that shapes current decisions about access and research. The resources are substantial according to geological assessments. Coal deposits formed when Antarctica supported forests millions of years ago exist throughout the Transantarctic mountains. Some seams are exposed where glaciers have retreated, visible proof of ancient vegetation. Iron ore deposits have been identified through magnetic surveys and surface sampling. Copper and other base metals appear in regions with volcanic and hydrothermal activity. Gold occurs in trace amounts in various rock formations, though whether concentrations justify extraction remains unknown without detailed surveys. Oil and natural gas represent the most valuable potential resources. Antarctica's continental shelf, particularly in the Ross and Weddell Seas, shows geological structures similar to productive oil-bearing regions elsewhere. Sedimentary basins formed over millions of years could contain hydrocarbon deposits. Some estimates suggest Antarctica might hold reserves comparable to major oil fields, though actual quantities are speculative. No exploratory drilling has occurred, and the technological challenges of extracting resources from beneath ice and ocean in extreme conditions make current exploitation impractical. The 7 claimant nations each control pie-shaped wedges extending from the coast to the South Pole or 2 specific latitude lines. The United Kingdom claims the Antarctic Peninsula and surrounding islands. Norway claims a vast sector, including Queen Maud Land. France claims Adelie Land on the coast facing Australia. Australia claims the largest area, roughly 42% of the continent. New Zealand claims the Ross Dependency. Chile and Argentina both claim overlapping portions of the Antarctic Peninsula, creating a triple overlap with British claims. These claims, asserted before the Antarctic Treaty, remain frozen in legal limbo, neither recognized by other nations nor relinquished by claimants. The United States and Russia, along with most other nations, don't recognize any territorial claims. Both reserve the right to make claims themselves if the treaty regime collapses. This creates a complex legal situation where claims exist on paper but carry no practical authority under current international law. The treaty system effectively suspended sovereignty disputes, allowing scientific cooperation while deferring the question of ownership indefinitely. The 1991 Protocol on Environmental Protection, sometimes called the Madrid Protocol, banned all mining and mineral resource extraction in Antarctica for 50 years. That protection expires in 2048, after which any party can request a review conference. Whether the ban will be extended, modified, or allowed to lapse is a question that generates increasing attention as the date approaches. Climate change makes Antarctic resources more accessible as ice retreats. Technological advances make extreme environment extraction more feasible. And global demand for minerals continues rising, creating economic pressure to reconsider restrictions. Could economic interests in Antarctic resources motivate suppression of archaeological discoveries? The theory suggests that ancient structures, if confirmed, might complicate territorial claims. If Antarctica hosted advanced civilizations, international law regarding indigenous heritage could apply, potentially overriding claims based solely on discovery and proximity. Nations with territorial ambitions might prefer to keep such findings quiet until legal frameworks favorable to their interests are established. The resource stakes, potentially trillions of dollars in mineral wealth, create sufficient motive for strategic information control. But the theory assumes discoveries exist to suppress. Without evidence of actual archaeological findings being hidden, it remains speculation about motive without proof of action. The resource politics are real. Multiple nations do have economic interests in eventual Antarctic exploitation. Whether those interests have led to suppressing pyramid discoveries requires evidence beyond the existence of resources and claims. Correlation isn't causation. Just because suppression would serve certain interests doesn't prove it's occurring. So could economic interests in Antarctic resources motivate suppression of archaeological discoveries that might complicate territorial claims? It's a theory that assumes significant findings exist to suppress and that nations can coordinate to hide them despite competing interests. The resource politics are documented and real. The connection to pyramid claims remains speculative, built on possible motives rather than demonstrated actions. Antarctica's mineral wealth creates stakes worth considering, but those stakes don't by themselves prove that discoveries have been hidden. Only that incentives for secrecy could exist if discoveries were made. From modern politics to ancient architecture, we return to a fundamental question. Why pyramids? If multiple cultures built pyramid structures independently, what makes this shape so universal? From modern politics to ancient architecture, we return to a fundamental question. Why pyramids? If multiple cultures built pyramid structures independently, what makes this shape so universal? Egypt, Mesopotamia, Mesoamerica, Sudan, China, Indonesia, pyramids appear across continents and millennia, built by cultures with no apparent contact. Some see this as evidence of a common source, a lost civilization that taught pyramid construction globally. Others point to independent invention driven by practical engineering and universal symbolism. The distribution is striking. Egypt's pyramids need no introduction. Monuments that have defined civilization's image for thousands of years. The Great Pyramid of Giza, built around 2560 BC, stands 481 feet tall, constructed from approximately 2.3 million stone blocks. Mesopotamian ziggurats, while stepped rather than smooth-sided, serve similar functions as monumental platforms connecting earth to heaven. The best preserved, the ziggurat of built around 2100 BC, demonstrates sophisticated engineering and astronomical alignment. Across the Atlantic, entirely separate from Old World developments, Mesoamerican cultures built pyramids on scales rivaling Egypt. Teotihuacan's Pyramid of the Sun, constructed around 200 AD, measures roughly the same base dimensions as Giza, though not as tall. Maya pyramids at Tikal, Palenque, and Chichen Itza display architectural sophistication and astronomical precision. The Aztec Templo Mayor in what is now Mexico City was still under active construction when Spanish conquistadors arrived in 1519. These weren't primitive imitations of Egyptian forms, but independent architectural traditions developed over millennia. Nubian pyramids in Sudan, numbering more than 200, represent another distinct tradition, built between 720 BC and 300 AD by the Kingdom of Kush. They're smaller and steeper than Egyptian pyramids, but demonstrate similar burial and ritual functions. In China, pyramid-shaped mounds served as imperial tombs, though most were earthen rather than stone. Indonesia's Gunung Padang, a terraced pyramid structure, has sparked debate about its age and purpose. The pyramid form appears wherever complex societies emerged. The similarities are undeniable. Most pyramids served religious or burial functions, connecting rulers to divine realms. Many aligned to cardinal directions or astronomical events, with precision requiring sophisticated knowledge. Pyramid construction often represents a society's peak achievement, mobilizing massive labor forces and demonstrating state power. The basic geometry, a broad base supporting a structure that rises to a point, appears consistently across cultures. These parallels fuel theories about shared origins or contact between ancient civilizations, but the differences are equally significant. Construction methods vary dramatically. Egyptian pyramids use precisely fitted stone blocks, some weighing multiple tons. Mesopotamian ziggurats employed mud bricks with bitumen mortar. Mesoamerican pyramids used stone rubble cores faced with carved stones and stucco. Chinese pyramid mounds are earth and clay. Materials reflect what was locally available, not a shared construction tradition. Purposes also diverge. Egyptian pyramids were tombs. Mesopotamian ziggurats were temple platforms, not burial sites. Maya pyramids often contained earlier structures buried within them, a practice unknown in Egypt. The pyramid form was adapted to different cultural needs. Timelines complicate claims of diffusion. Egyptian pyramids date from around 2600 BC. Mesopotamian ziggurats appear slightly later. Mesoamerican pyramids begin construction around 1000 BC, centuries after Old World examples. Nubian pyramids post-date Egyptian ones, showing clear influence through geographic proximity and historical contact. But the time gaps between Egyptian and Mesoamerican traditions span millennia. If a common source taught pyramid building globally, why such delays? And why would techniques and purposes differ so dramatically if taught by a single culture? The engineering provides another perspective. Pyramids are structurally stable. The shape distributes weight efficiently, allowing tall structures without advanced materials. Any culture discovering stone construction and seeking to build tall monuments might independently arrive at pyramid forms through trial and error. Early attempts at vertical walls would fail. Pyramid shapes, with their broad bases and inward-sloping sides, naturally resist collapse. The universality might reflect convergent evolution, different cultures discovering the same engineering solution to similar problems. Symbolism offers yet another explanation. Mountains hold religious significance across cultures, seen as dwelling places of gods or connections between earthly and divine realms. Artificial mountains, pyramids, extend that symbolism into constructed space. The vertical axis from earth to sky represents human aspiration toward transcendence. These concepts aren't culture-specific, but emerge from shared human experiences of landscape and spirituality. Similar symbols can arise independently when cultures face similar existential questions. So do global pyramids prove a lost civilization spread the design worldwide? Or do they demonstrate convergent evolution? Different cultures independently discovering that pyramids are stable, monumental, and symbolically powerful. The evidence favors independent invention, with each culture adapting the basic form to local materials, beliefs, and engineering capabilities. Similarities reflect human universals, practical constraints of building tall structures, and shared symbolic associations, not necessarily ancient contact. The pyramid shape emerges not from a single source, but from multiple discoveries that the form works, both physically and spiritually. While pyramid debates span the globe, Antarctica offers unique evidence of another kind: meteorites preserved in pristine ice, revealing secrets about our solar system and raising questions about what else the ice preserves. While pyramid debates span the globe, Antarctica offers unique evidence of another kind: meteorites preserved in pristine ice, revealing secrets about our solar system and raising questions about what else the ice preserves. Antarctica is the best place on Earth to find meteorites. The ice sheet acts as a natural collection and concentration system, gathering space rocks that fall across the continent and delivering them to specific zones where they accumulate. Their dark forms stand out against white ice. Since systematic searches began in 1969, researchers have recovered over 45,000 meteorites from Antarctica, including rare specimens found nowhere else. Why Antarctica? Several factors combine to make the continent ideal for meteorite recovery. First, meteorites that fall on ice are preserved rather than weathering away as they would in most environments. Rain, wind, and biological processes that degrade space rocks elsewhere don't operate in Antarctica's extreme cold and dryness. A meteorite that fell 1 million years ago can remain nearly pristine, its surface and interior protected by ice. Second, the ice sheet's movement concentrates meteorites in predictable locations. As ice flows outward from the interior, it encounters mountain ranges that block its path. Ice sublimates, evaporating directly into vapor, leaving behind anything embedded within it. Meteorites accumulate in these zones, called blue ice areas, where centuries of accumulation create dense collections. Third, visibility makes discovery straightforward. Dark meteorites, typically iron-rich or carbonaceous, contrast sharply against white and blue ice. Researchers walking or flying over blue ice areas can spot specimens from significant distances. No excavation is required. The meteorites sit on the surface, ready for collection. This ease of discovery, combined with concentration in specific zones, makes Antarctica far more productive than deserts or other traditional meteorite hunting grounds. The statistics are remarkable. The Antarctic Search for Meteorites program, ANSMET, operated jointly by NASA and the Smithsonian Institution, has conducted annual expeditions since 1976. Japanese programs began even earlier. These systematic searches have recovered meteorites representing every major class: stony chondrites that date to the solar system's formation, iron meteorites from differentiated asteroids, achondrites from planetary surfaces. Some are fragments of Mars and the Moon, blasted into space by ancient impacts and eventually falling to Earth. Antarctica provides the most diverse collection of extraterrestrial material available for study. Among Antarctica's meteorite finds, ALH 84001 stands out. Discovered in Allen Hills in 1984, this 4.1-pound rock was initially catalogued as an unusual achondrite. Only in 1994 did scientists determine its Martian origin, identified through trapped gas bubbles matching Mars's atmospheric composition, measured by Viking landers. Then, in 1996, researchers announced that ALH 84001 contained features possibly indicating ancient Martian life. Microscopic structures resembling fossilized bacteria, organic molecules called polycyclic aromatic hydrocarbons, and mineral formations consistent with biological activity. The announcement sparked global debate about life beyond Earth. Subsequent research has challenged the biological interpretation. Most scientists now believe the features in ALH 84001 have non-biological explanations formed through chemical processes rather than life. But the meteorite remains significant. It proves that material can travel from Mars to Earth, that rocks preserve detailed records of planetary conditions billions of years ago, and that Antarctica's ice can protect such evidence indefinitely. ALH 84001 is 4.5 billion years old, nearly as ancient as the solar system itself, yet it survived intact because Antarctic ice shielded it from weathering. Antarctica's ice preserves meteorites for millennia without degradation. This raises a question. If ice can preserve 4.5 billion-year-old space rocks without damage, could it also preserve artifacts from human activity? The answer depends on timing. Meteorites that fall onto ice remain on or near the surface until concentration mechanisms bring them together. They predate the ice sheet or fall onto it after formation. Human artifacts would require different circumstances. Either they were placed on ice recently, within centuries or millennia, or they were built before the ice sheet formed and somehow became incorporated into it as glaciation advanced. The former is unlikely to include ancient pyramids. The latter requires ice younger than evidence suggests, or human presence before the ice formed, contradicting the 34 million year timeline. The preservation power is undeniable. Ice protects better than almost any environment. But preservation requires objects to exist in the ice, not beneath it as bedrock formations. Meteorites demonstrate what ice can do for material on its surface. Whether that extends to structures buried beneath depends on when those structures were built and how they relate to ice formation, questions the meteorites themselves cannot answer. From what ice preserves to what technology might reveal, we turn to future expeditions and advancing tools that could finally answer questions about what lies beneath Antarctica's frozen surface. From what ice preserves to what technology might reveal, we turn to future expeditions and advancing tools that could finally answer questions about what lies beneath Antarctica's frozen surface. Technology is advancing rapidly. Ground-penetrating radar becomes more powerful each year. Autonomous submersibles can explore subglacial lakes without contaminating them. Ice drilling reaches deeper into the ice sheet, and artificial intelligence processes satellite imagery at scales impossible for human analysts, identifying patterns that might otherwise remain invisible. Within decades, we may have comprehensive maps of everything beneath Antarctica's ice. Ground-penetrating radar has improved dramatically since the 1990s. Early systems penetrated a few hundred meters with limited resolution. Modern systems reach through miles of ice while providing clearer images of subsurface features. Next-generation radar, currently in development, promises even greater capabilities. Phased array systems can steer beams electronically, scanning wider areas without physically moving equipment. Ultra-wideband radar improves resolution, potentially distinguishing features just meters across, even through thick ice. Lower frequency systems penetrate deeper, possibly reaching through the entire ice sheet to bedrock across the continent's full extent. These advances matter for identifying structures. Current radar can detect large features, lakes, mountains, major cavities. but smaller objects remain below resolution thresholds. If artificial structures exist beneath the ice, their size relative to ice thickness determines detectability. A pyramid, 1,000 feet tall, beneath 2 miles of ice, might appear as a subtle anomaly in current data, easily missed or attributed to geology. Improved resolution could reveal artificial features by showing regular geometries, right angles, or arrangements that natural formations don't produce. The technology to see beneath Antarctica comprehensively is approaching viability. Subglacial lake exploration represents another technological frontier. Lake Vostok, sealed for possibly millions of years, remains largely unexplored because drilling into it risks contamination. Introducing surface microbes or chemicals could destroy the pristine ecosystem. But technology is catching up. Hot water drills that sterilize water through heating and filtration allow cleaner access. Autonomous submarines designed to explore without human presence can map lake floors and collect samples. These systems, developed partly for potential missions to Europa's subsurface ocean, could deploy in Antarctic lakes within the next decade. Why does lake exploration matter for pyramid claims? Subglacial lakes exist in cavities where ice melts from below due to geothermal heat or pressure. If structures exist in these regions, they might be partially or fully submerged in lakes beneath the ice. Exploring these environments could reveal whether they contain only water and sediment, or whether human artifacts or construction exists in these hidden spaces. The lakes represent accessible voids where investigation doesn't require drilling through solid ice to bedrock. Ice core drilling continues pushing deeper. The oldest ice cores currently reach back roughly 800,000 years. Projects are underway to recover cores extending past 1 million years, accessing ice that formed during critical periods of climate history. But drilling also provides opportunities to sample what's embedded in ice. If artifacts or unusual materials exist within the ice sheet itself, rather than at the bedrock base, drilling campaigns might encounter them. The probability is low, but systematic drilling across wide areas increases chances of discovery if anything anomalous exists to be found. Artificial intelligence offers perhaps the most immediately applicable advance. Analyzing satellite imagery manually is time-consuming and subjective. Human analysts might miss subtle patterns or interpret ambiguous features inconsistently. Machine learning algorithms can process vast quantities of satellite data, identifying patterns humans overlook. AI trained on known artificial structures, temples, cities, monuments, can then scan Antarctic imagery, searching for similar features. The technology has already proven successful in discovering buried cities in Central America and lost structures in North Africa. Applying it systematically to Antarctica could reveal features previous analyses missed. Autonomous vehicles, both surface and aerial, extend exploration reach. Drones equipped with high-resolution cameras and sensors can survey remote areas without risking human teams. Ground rovers can traverse blue ice areas, searching for surface features or meteorites. Under-ice vehicles can explore the base of ice shelves and subglacial water systems. These platforms reduce cost and risk while increasing coverage. Within 20 years, autonomous systems might conduct continuous surveys across Antarctica, monitoring for changes and documenting features too remote for human expeditions. Timeline matters. These aren't science fiction technologies, but capabilities either currently operational or in active development. Next-generation radar systems will deploy within 5 to 10 years. Subglacial lake exploration using sterilized probes could begin this decade. AI analysis of existing satellite archives is ongoing. The comprehensive mapping of subsurface Antarctica will happen. The question is what it will reveal. So will advancing technology soon reveal whether structures exist beneath Antarctic ice. If they're there, improving radar, AI analysis, and eventual physical access will find them. If they're not, the same tools will map every geological feature comprehensively, settling the question through exhaustive survey. The technology to answer these questions is coming. Whether the answers transform our understanding or confirm conventional geology. Within the lifetime of today's researchers, Antarctica's subsurface will be as well mapped as its surface, and the mystery of the pyramid formations will move from speculation to settled fact, whichever direction that fact points. While scientific expeditions require years of planning and international coordination, another phenomenon is bringing people to Antarctica faster than ever: tourism. And that raises questions about access, discovery, and what private visitors might observe. From surface tourism to the depths beneath, we turn to one of Antarctica's most intriguing mysteries. Lake Vostok, a subglacial body of water sealed for millions of years, and what it might contain. Beneath Russia's Vostok Station lies one of the world's largest lakes, 160 miles long, 30 miles wide, with depths exceeding 1,600 feet. It sits beneath 2.5 miles of ice and has been isolated from the surface for potentially 15 million years. What exists in that ancient, dark water? The question has fascinated scientists and sparked theories ranging from unknown microbes to preserved ancient structures. Lake Vostok's existence was suspected long before confirmation. Scientists noticed that the ice sheet above Vostok Station behaved differently than elsewhere, suggesting liquid water beneath. But definitive proof came through airborne radar surveys in the 1990s. The radar revealed a vast void beneath the ice, flat and level as only a liquid surface can be. In 1996, Russian and British researchers confirmed Lake Vostok as one of Earth's largest subglacial lakes, comparable in area to Lake Ontario, though much deeper in places. The discovery raised immediate questions. How could liquid water exist under such conditions? Pressure provides part of the answer. The weight of 2.5 miles of ice above creates enormous pressure that lowers water's freezing point. Geothermal heat from Earth's interior contributes additional warmth. Together, these factors maintain liquid water at temperatures around -3 degrees Celsius, below normal freezing, but liquid under pressure. The lake isn't warm by any standard humans would recognize, but it's not solid ice. For decades, Russian researchers have been drilling through the ice above Lake Vostok. The drilling began in the 1970s as part of ice core research, not initially targeting the lake. As the drill approached the lake surface, concerns about contamination intensified. The drill used kerosene and freon to prevent the hole from freezing shut. Introducing these chemicals into a pristine ecosystem sealed for millions of years would be catastrophic for any life that had evolved there. International pressure mounted to stop drilling before breaching the lake itself. But in February 2012, Russian drilling teams broke through. At a depth of 12,365 feet, the drill penetrated the ice-water interface, reaching Lake Vostok's surface. Samples of accretion ice, lake water that had frozen onto the bottom of the ice sheet above, were recovered and analyzed. These samples, while not pristine lake water, provided the first direct evidence of what exists in the lake. The results were remarkable. Scientists identified genetic material from at least 105 distinct microbe species. Some resembled known bacteria from surface environments, possibly introduced through ancient ice formation when the lake was last exposed. Others appeared unique, potentially adapted to the lake's extreme conditions over millions of years of isolation. The microbes survive without sunlight, with minimal nutrients, in near-freezing water, under crushing pressure. They represent an ecosystem functioning in conditions once thought incompatible with life. These findings have implications beyond Antarctica. If life thrives in Lake Vostok, it strengthens the case for possible life on Europa, Jupiter's moon, or Enceladus, Saturn's moon. Both have subsurface oceans beneath thick ice shells, environments remarkably similar to Lake Vostok. The lake serves as an analogue, proving that life can persist in extreme isolation. NASA and other space agencies study Antarctic subglacial lakes to prepare for future missions to these icy worlds. But alongside scientific findings, speculation persists. Some theories propose that Lake Vostok contains more than microbes. One claim involves a magnetic anomaly detected near the lake's center. Magnetic surveys show an unusual signature, stronger than surrounding areas and concentrated rather than diffuse. Natural explanations exist: iron-rich rocks in the lakebed, volcanic features, mineral deposits. But alternative interpretations suggest artificial sources, metallic structures, perhaps bases or monuments submerged in the lake. The magnetic anomaly is real, documented in scientific surveys. Its interpretation remains contentious. Geologists point to numerous natural processes that create magnetic anomalies, volcanic intrusions, mineralization zones, structural features in bedrock. Antarctica's geology is complex and incompletely mapped. Finding an unexplained anomaly is not surprising. What would be surprising is if every magnetic signature had immediate geological explanation. Science progresses by investigating anomalies, not by assuming they must be artificial, because they're not yet fully understood. Environmental concerns limit further exploration. Drilling directly into Lake Vostok with current methods risks contamination. Russian drilling in 2012 used controversial techniques that many scientists believe compromise the samples. Future exploration requires cleaner methods, sterilized probes, hot water drills that don't use chemicals, autonomous submarines that can explore without introducing surface contaminants. These technologies exist, but haven't yet deployed in Lake Vostok. The lake remains largely unexplored beyond the initial breakthrough. Theories about ancient structures preserved in the lake face practical challenges. The lake has been sealed for 15 million years. If structures exist there, they would predate not only human civilization, but human evolution. They would be older than any ice age, older than modern mammals, placed there when Antarctica was already frozen. The timeline makes artificial structures implausible unless we abandon everything known about Antarctic glaciation and human origins. The magnetic anomaly might merit investigation, but explaining it through ancient construction requires more assumptions than the evidence justifies. So what lies beneath Lake Vostok? Science has found microbes adapted to extreme conditions, life thriving in perpetual darkness. Theories about ancient structures or preserved artifacts require evidence beyond magnetic anomalies and speculation. The lake represents the kind of environment where preservation is possible: cold, sealed, stable. But accessing it without contamination remains technically challenging. What's down there will be revealed through patient scientific investigation, not speculation. Lake Vostok holds secrets, but they appear to be biological and geological rather than archaeological. From specific mysteries like Lake Vostok to the broader questions that sparked this journey, we return to where we began. Those pyramid-shaped peaks rising from Antarctic ice, and what they mean for our understanding of human history and Earth's past. From specific mysteries like Lake Vostok to the broader questions that sparked this journey, we return to where we began. Those pyramid-shaped peaks rising from Antarctic ice, and what they mean for our understanding of human history and Earth's past. We've examined satellite imagery showing geometric formations in the Ellsworth Mountains. We've reviewed ancient maps that some claim depict Antarctica before ice. We've explored geological processes that create pyramid shapes naturally. We've considered timelines, expeditions, whistleblower accounts, and scientific consensus. Where does that leave us? The evidence exists on multiple levels. Satellite imagery documents pyramid-shaped peaks in Antarctica. That's not disputed. The formations are real, captured by multiple satellite systems, visible at specific coordinates that anyone can verify through Google Earth. The shapes are striking, geometric enough to warrant attention. 3 peaks in the Ellsworth Mountains display proportions and angles that superficially resemble constructed pyramids. Additional formations on the Antarctic Peninsula show similar characteristics. These are facts, observable phenomena documented through technology. Ancient maps add another layer. The Piri-Reis map of 1513 and the Orontes Phineas map of 1531 both show southern landmasses that bear some resemblance to Antarctica. The level of detail, particularly coastlines and interior features, exceeds what Renaissance cartographers should have known if Antarctica was undiscovered until 1820. Whether these maps represent genuine ancient knowledge or theoretical geography mixed with coincidence remains debated. The maps exist. Their interpretation divides scholars. Operation High Jump's early termination in 1947, the whistleblower accounts claiming suppressed discoveries, the Antarctic Treaty's control over access, all create a framework where suppression could theoretically occur. The motivations are plausible. Territorial claims, resource interests, paradigm protection. Each provides reasons why nations might hide archaeological findings. But plausible motives don't prove actual suppression. The gap between could happen and did happen requires evidence beyond theoretical possibility. Geological explanations are robust. Horn pyramids form through well-understood erosional processes. The Matterhorn, Ama Dablam, Mount Assiniboine. Countless other peaks worldwide display pyramid geometry created entirely by glacial carving. Antarctica's extreme glaciation would produce such forms more commonly than less glaciated regions. The angles observed in Antarctic formations fall within ranges that natural erosion produces. Without ground-level examination showing tool marks, construction features, or materials inconsistent with natural geology, the formations match expectations for eroded peaks. Yet the timeline problem persists. Antarctica has been frozen for 34 million years, according to ice core data, sediment analysis, and multiple independent dating methods. Human civilization emerged roughly 12,000 years ago. The gap is vast, seemingly insurmountable. For artificial structures to exist in Antarctica, either human history extends millions of years further back than any evidence indicates, or Antarctica's ice formed far more recently than geological consensus holds. Neither scenario fits current data. Alternative theories like Ice Age coastal exposure or crustal displacement attempt to bridge the gap but lack supporting evidence. Göbekli Tepe demonstrates that early humans were more capable than once believed. If hunter-gatherers built sophisticated stone monuments 11,500 years ago, the window of plausibility for ancient achievements expands. But Göbekli Tepe was built with Stone Age technology in a habitable environment. Antarctica, even with exposed coasts during Ice Age sea level drops, would have presented conditions far more extreme. And crucially, no archaeological evidence of human presence in Antarctica has been found. No tools, no campsites, no remains. Capability alone doesn't prove presence. The debate reveals different standards of evidence. Alternative researchers point to anomalies, maps showing unexpected knowledge, formations with precise geometry, accounts of suppressed discoveries. They argue these warrant investigation and open-minded consideration. Mainstream science demands reproducible findings, ground verification, artifacts, anything beyond resemblance and speculation. Both sides talk past each other, one seeing patterns worth exploring, the other requiring proof before overturning established models. What would settle the debate? Ground expeditions to the formations, examining rock surfaces for construction marks, improved radar revealing internal structures inconsistent with natural geology, artifacts recovered from Antarctic sites, material analysis showing transported stones rather than natural bedrock, mathematical analysis proving geometric precision beyond what erosion produces. Any of these would force re-evaluation. Their absence keeps geological explanations dominant while leaving alternative theories in the realm of intriguing speculation. Technology is advancing. Within decades, comprehensive subsurface mapping will reveal everything beneath Antarctic ice. Improved radar, AI analysis of satellite data, autonomous exploration vehicles, all promise to answer questions that currently rely on limited remote observations. If artificial structures exist, these technologies will find them. If they don't, the same tools will document natural geology so thoroughly that the question resolves through exhaustive survey. The Antarctic pyramids present us with images that demand explanation. Mainstream geology provides one: natural erosion, creating pyramid shapes, as it has in glaciated mountains worldwide. Alternative theories provide another: remnants of lost civilizations, suppressed by politics or waiting for discovery. What separates these explanations is evidence, testable, reproducible, comprehensive evidence that would transform speculation into demonstrated fact. The formations exist. That's not in dispute. What they represent, geological curiosities shaped by ice over millennia, or architectural wonders built by unknown builders, depends on evidence still being gathered. Antarctica keeps its secrets beneath miles of ice. Whether those secrets include human construction or only natural wonders, we'll know when technology and exploration reach the places speculation currently fills. And that's where this journey ends, not with answers, but with questions that persist, because the frozen continent holds its silence. What lies beneath Antarctica's ice? We don't fully know, but we're closer to finding out than ever before. History isn't just the story of what we've uncovered. It's also a landscape of claims, satellite images, and mysteries that remind us how much remains out of reach. Across this journey, we've looked at pyramid-shaped peaks, ancient maps, expedition reports, geological processes, and technological advances. Some evidence compels, other claims rest on interpretation, and much more waits beneath the ice that could take decades to fully explore. So now it's your turn. What do you think about Antarctica's pyramid formations? Natural erosion, suppressed discovery, or something else entirely? Drop your theories in the comments, and I'll be replying to my favorite ones. Make sure to check out our channel for more videos exploring Earth's deepest mysteries. And as always, until next time, stay curious